Okay, so we might start soon, but just before we do, if I can click the right buttons. Hi, everyone. My name is Malaz, and I'm going to be your tutor. I'm going to be presenting psych today. Just a few housekeeping things first. Feel free, it's totally fine for you to have your cameras off. That's totally okay if you want, but it's nice to see faces. So that's also cool, your choice. I've just shared my screen to this platform called Menti, and it's going to just be really helpful for questions. So because there are more than 30 people in the chat, filtering through questions in the chat might be a little bit difficult. So if you go on the website and you use this code and you can just submit questions, and we'll have a section towards the end where I can just sift through and answer all your questions. So you can do that. Oh, that's so sweet. Oh, I feel like, so I'm at uni, and I feel like this is how my uni tutors must feel when people like interact. It's really nice. So beautiful. So yeah, so you can use that throughout the chat. Hopefully you've gotten the code down by now. But you can answer, yeah, so throughout the presentation, you can put questions on there, and then towards the end, I can sift through them, and we can have a go at answering those. So I've also put a link to SurveyMonkey in the chat. So we've partnered with, so Skyline's partnered with the UBS to provide these amazing sessions, and we really just want to get some data and information about how you feel about it. So it'd be great, even if you have to leave a little bit early, if you could fill out the forms. The way that it works is that once you fill out the forms, there's a section in there where you provide your email, and then that's how the PowerPoint slides and the recordings get sent out to you. If you want to get the recordings for another subject, you can hop onto the Skyline Skyline.org website, and then you can also, there's an option in there. Oh, I'll send it again. There's also an option in there to get slides from another course. If you pop your email in, as soon as they're available, they'll be sent to you. Can you see that now, Leah?
Yep.
Yeah, perfect, great. So without further ado, I'll share my PowerPoint slides. Cool. So like I said, my name is Malaz. I did psych. I graduated last year. Psych was probably my favorite subject. So.
Oh, kind of, yeah.
Great. So just some housekeeping again. Try to make sure that your mics are on mute, just if you don't want to speak. And then, yeah, that's it so far. So if we use the question function for the questions, that would be amazing. So I just wanted to acknowledge the traditional custodians of the land, which I am on. So I'm on land of the Kulin Nation, and I pay my respects to the elders past, present. They hold the memories, the traditions, the culture, and the hopes of Aboriginal and Torres Strait Islander peoples across the nation. A bit of a guide through how today is going to work. We're just going to roll through, 3 AOS 1, AOS 2. We'll briefly touch on research methods at the end, and we'll have a bit of a summary and questions. Also, there might be quite a lot of information on the slides. I might not go through all of it, but it's more for your notes, so you have more information there if you wanted to use the slides to help you answer practice questions or anything like that. Beautiful. So just also, lots of housekeeping. On the top left-hand corner of each slide, there's a little thing, so KK1, and then it's got a bit of a description. So that corresponds to the relevant key knowledge point on the study design, and it will restart for every area of study. So we start with the human nervous system, and the main things that you have to know about it is its essential role. So the human nervous system helps us receive information, process information, and then respond to that information. So the central nervous system, so the human nervous system is made up of the central nervous system and the peripheral nervous system. So the central nervous system is made up of the brain and the spinal cord. We know the brain is the control center for all human behavior, and the spinal cord is a long, thin bundle of nerve tissue that extends from the base of our skull all the way down to our lower back. So the spine contains white matter, which is composed of nerve fibers that connect distant brain areas to each other, and grey matter, which is composed of nerve cell bodies and their local connections, which are mainly located near the center of the spine. this dot point, there tends to be multiple choice questions that ask you to understand the difference between white matter and how it connects distant brain areas, and grey matter and its local connection. So even if you don't know too much about it, it's just important to acknowledge that they're different roles. Beautiful. So that's our central nervous system. The peripheral nervous system is everything else on the outside. So the PNS carries messages to and from the central nervous system, and it's a network of nerves that branch out from the central nervous system to all other parts of the body. So the PNS delivers sensory information from sensory receptors via afferent nerves to the central nervous system, and transmit messages from the central nervous system to the muscle glands and organs via efferent nerves. So the acronym that's really great for memory is SAME. So sensory information is coming from the outside, goes up afferent nerves, through afferent nerves, motor information from the central nervous system down to the body through efferent nerves. Now, the PNS is comprised of the somatic nervous system and the autonomic nervous system. So the somatic nervous system carries messages from sensory receptors in the body to the CNS, and motor messages from the CNS to the skeletal muscles. It conveys messages from the sense organs, I thought I was going to sneeze, to the CNS, and controls the skeletal muscles responsible for voluntary movement and sensory function. So sensory neurons are specialized cells, again, carrying efferent information to the CNS. Motor neurons are specialized cells that carry efferent information from the CNS to skeletal muscles. And we also have interneurons that connect, or connecting neurons, and they interlay information between sensory and motor neurons. And they can mainly be found in the CNS. Then we have the autonomic nervous system. So the autonomic nervous system connects the central nervous system to internal organs and glands and is self-regulating. So if we think of, in comparison to the somatic nervous system, this one happens automatically. We don't think about it, whereas there's effort and directed motivated actions when we're carrying out things to do with like the sensory nervous system to some extent. So we've got two divisions of the autonomic nervous system that complement or balance each other, but generally have opposite effects. So we have the sympathetic nervous system, and that's responsible for increasing the activity of most visceral muscles, organs, and glands in times of vigorous activity, stress, or threat. And we have the parasympathetic nervous system. So that's responsible for decreasing activity of most visceral muscles, organs, and glands, and restoring bodily function to normal state or homeostasis. The way I remembered it was the sympathetic nervous system is similar to that, like a snake. So it starts with the same letter. Most people, when they see the snake, they freak out. Heart rate increases, pupils dilate to allow more light in. We breathe a lot faster. We've got more blood pumping throughout our body to provide oxygen. Whereas the parasympathetic nervous system is like the parachute. So it calms everything back down again. A heart rate will decrease, increase salivation, because the increased salivation, pupils are going to constrict. We're not on such a heightened level anymore. So when we're talking about conscious and unconscious responses, the distinction is that a conscious response to sensory stimulus is one that involves awareness. So the response is usually voluntary and it's an intentional reaction. So I want the remote, I send signals, I reach my arm out, I get the remote and I grab it. As opposed to an unconscious response to a sensory stimulus, and that's one where it doesn't involve awareness. So it's involuntary, unintentional, we can't ordinarily control its occurrence. So an example of this is a spinal reflex. So for example, we'll take the of touching a hot frying pan. So sensory neurons carry the message along the sensory pathway to the spinal cord. So we've touched something, sensory receptors carry the information through sensory neurons up afferent pathways to the spinal cord. Interneurons in the spinal cord, they relay the motor message, the message to motor neurons. And the motor neurons, so we haven't reached the brain yet, the motor neurons carry the message along the motor pathway to the muscles, causing a withdrawal reflex. So before the messages reach the brain, we've let go of the hot frying pan. While the reflex is occurring, so after we've let go of the frying pan, the neurons continue to carry the message to the brain, and then we will perceive pain in the area of the brain that processes this information. So the spinal reflex is an unconscious response because there's a reflex arc in the spinal cord. The information doesn't reach our brain. We don't make a conscious response. It's an automatic response. We drop the frying pan. There are questions in exams that ask you to outline how the spinal reflex occurs. I found that listing it out in this way was the best way for me to understand it and then to be able to write it down in a response. Then we look at the role of the neuron in reception and transmission of information. So a neuron is an individual nerve cell that is specialized to receive or process and or transmit information. So there are neurons all over our body and our brain, and there are neural circuits, and there are some circuits that are stronger than others because we use them more. But we need to know sort of the structure and the functions of different parts of the neurons. So you have dendrites, which are an extension of a neuron that detect and receive information from other neurons. Then we have the soma, where the signals from the different dendrites are joined and passed on down the neuron. We have the axon, which is a single tube-like extension that transmit neural information to other neurons. Then we have myelin, and myelin is a white fatty substance that's made up of glial cells that surrounds and insulates the axon, and it provides faster transmission faster transmission from along the neuron, and it also helps to protect from interference from other neurons. Axon terminals are the branch-like structures at the end of the axon, which have terminal buttons on them, and the terminal buttons are the small sacs that store and secrete the neurotransmitter that is manufactured by that specific neuron. Then we have the synaptic gap, which is the tiny gap that exists between the terminal buttons of the presynaptic neuron, so the neuron that is sending the information, and the postsynaptic neuron, the neuron that's receiving the information. And then we have the synapse, and that's just the site where communication occurs between adjacent neurons. So neurotransmitters are chemical substances that are produced by neurons and that carry messages to other neurons or cells in muscles, organs, or other tissues. So the way that they work is that they attach to the receptor sites of the postsynaptic neuron, and we'll go through that in the next slide a bit more specifically. So some neurons have what we call an excitatory effect. So they stimulate the postsynaptic neuron or activate the postsynaptic neuron to perform its actions, to perform its functions. Whereas other neurotransmitters have an inhibitory effect, and they block or prevent postsynaptic neurons from firing. So glutamate is an example of a primary excitatory neurotransmitter, and it's involved in most aspects of normal brain functioning, including perception, memory, learning, and movement. And GABA is a primary inhibitory neurotransmitter that is involved in fine-tuning neurotransmission at the best or optimal level. So the inhibitory actions of GABA counterbalance the excitatory effects of glutamate and vice versa. But we need both. So in terms of how neurotransmitters bind, so each type of neurotransmitter has a chemically distinct shape. When the neurotransmitter is released by the presynaptic neuron, it searches for the correctly shaped receptor site on the dendrite of the receiving, the postsynaptic neuron. In order for the neurotransmitter to bind, the neurotransmitter shape has to match the shape of the receptor site on the postsynaptic neuron. The binding unlocks the postsynaptic neuron's response so that the neurotransmitter causes changes to the neuron. And then this chemical process is known as the lock and key process, whereby the neurotransmitter acts as a key and the receptor site acts as a lock, but only for that specific key. So it's important to understand that concept. Exams will often include a question regarding this in some way, shape, or form. And really, you could shove all those stop points together and that could be your answer. Then we look at the effects of neurotransmitter, so interference to neurotransmitter function, and we examine that through looking at the role of Parkinson's disease. So Parkinson's disease is a central nervous system neurodegenerative disorder characterized by both motor and non-motor symptoms. So motor symptoms result from the degeneration and loss of neurons in the substantia nigra, which is an area, it's located in the midbrain, and it plays a role in the control of voluntary muscle movement, so they can be executed in smooth and coordinated manner. Neurons of the substantia nigra produce a neurotransmitter called dopamine, and when the substantia nigra is diseased or damaged, the amount of dopamine that's available for motor activity reduces as neurons gradually die. So one role of dopamine is it carries messages from the substantia nigra on how to control body movements to the nearby basal ganglia, but also to the motor cortex and the frontal lobes. So the logic is that when you have fewer neurons, it leads to less dopamine production, which means that there are fewer and irregular dopamine messages to the basal ganglia and the motor cortex. And that means that we have disruption to planning, coordinating, and initiating muscle movements. Parkinson's is also described as an idiopathic disease because we don't know what causes it, but we have located that, it's in this area of the brain, and it's the degeneration of neurons, the dopamine producing neurons, that have this effect on our ability to carry out movement. So motor symptoms include tremors, so that's continuous shaking of the body, muscle rigidity, so where the muscles are just unable to relax and feel quite tight, bradykinesia, so that's meant to say slow voluntary movement, so disruption when initiating, stopping, and executing ongoing movement, and postural instability, so it's an inability to remain steady or upright and having balance problems. Now, there are non-motor symptoms of Parkinson's as well, and these include decrease or loss of sense of smell, sweating, and increased sensitivity to temperatures, continuous and unrelenting fatigue, or mental health problems such as panic attacks or anxiety disorder. Now, while there's no known cure for Parkinson's disease, because we understand that it's a degeneration of dopamine producing neurons, there's medication that can either convert or initiate the role of dopamine. One of these is called levodopa, and it's a chemical substance that is converted to dopamine by neurons and thereby replaces the dopamine that is lost. It can be taken alongside another medication called carbidopa, which delays the conversion of levodopa into dopamine until it reaches the brain. There's also the possibility to engage in deep brain stimulation, and it's a surgical procedure that enables us to electrically stimulate the brain and use electrodes to target certain areas with tiny amounts of electrical current to block the abnormal neural messages that cause the difficulty in controlling motor movement and motor symptoms. So now we move on to stress. So the different sources of stress, some of them are more, we might be more acclimated to them or used to them because they're just involved in everyday life, whereas some are quite unexpected and then have a significant impact on the way that we can live our lives if we can't cope or quickly adjust. So stress is a state of physiological and psychological arousal produced by internal or external stresses that are perceived by the individual as challenging or exceeding their ability and resources to cope. So, for example, internal stressor might be something like concerns about dying, and that doesn't originate outside of an individual, but it's more to do with them and their thoughts, and that's a totally valid stressor. On the other hand, external stressors might be exams coming up and a lot of pressure to do well, so that might also cause stress. We have two different types of stress in terms of eustress and distress. So we talk about eustress in terms of it's a positive psychological response to a stressor. We have positive psychological states such as feeling enthusiastic, motivated, excited, alert, sort of the butterflies in your stomach sort of stress. Stress. And then distress, which is the negative psychological response to a stressor, as indicated by the presence of negative psychological states such as anger, anxiety, irritability, or tension. And then we talk about the different sources of stress. So daily pressures, little problems of everyday life that might be events that annoy us or bother us, which make us angry and upset and cause what we call like an acute ongoing stress. Life events that force us to change or adapt to new circumstances. We have acculturative stress, which refers to the stress that people experience in trying to adapt to a new culture and living in it for a considerable period of time. So, for example, language difficulties, ethnic discrimination, loneliness, homesickness, they can all be sources of acculturative stress. A major stressor is an event that is extraordinarily stressful for almost everyone who experiences it. So, for example, wars or conflicts tend to be quite disturbing for most people that will experience it, but it can manifest in different ways. And then we talk about catastrophes, so unpredictable events that cause widespread suffering or damage. The easiest example is natural disasters, earthquakes, floods, things like that. So we've got a few different models of stress that enable us to examine the role of stress through biological processes, but also psychological processes. So in terms of the biological processes, we have two sort of models that we look for. One of them is the fight, flight, freeze response, and that's an involuntary physical response to a sudden and immediate threat or stressor in the environment in readiness to either fight, so we confront and fight off the threat, we flight, so we escape by running away to safety, or we freeze, we keep absolutely still and silent in aims of avoiding detection. So in terms of the fight, flight response, to prepare our bodies for either alternatives, all of our energy is directed from non-essential body systems to those that are going to help us either outrun or outfight the threat. So our digestion stops and our salivation stops because all the energy is going to making sure that our heart is pumping blood around our body for oxygen. Our pupils will dilate to make sure we're letting more light in so we can see. So there's a brain-body pathway that enables us to do this, and it's called the sympathetic adrenomedullary system, or SAM. So when we sense a threat, a signal is sent to the hypothalamus, and the sympathetic nervous system stimulates the adrenal medulla, and the adrenal glands secrete hormones called adrenaline and noradrenaline into the bloodstream, or our stress hormones. They circulate in the bloodstream and they activate those various organs, including the heart and the lungs and the liver and the kidneys. And that results in the bodily once the fight-flight reactions. And then once the stressor has been removed by the parasympathetic nervous system, once the stressor has been removed, the parasympathetic, so the parachute will take over, and the high levels of bodily arousal gradually subsides. Now, in terms of the freeze reactions, there might be some situations where our bodies just don't enable us to either fight or flight. So we might go into a freeze state where we're unable to move or act. Before this immobility sets in, there's like a reflexive orienting response of the head or eyes toward the direction of the threat, accompanied by hypervigilance. Now, the biological processes that underlie the freeze reaction aren't 100% understood, but this is what's presumed to happen. So in preparation for the threat, the sympathetic nervous system is activated, right? It always precedes the freeze state, and then it becomes a part of this state. However, when this state is initiated, the energy-conserving actions of the parasympathetic nervous system dominate over the existing effects of the sympathetic nervous system. So it results in a condition characterized by both energy conservation and a mobilized state ready for action. The best way to understand this, if it seems confusing, when we go into a freeze state, we press on the gas. But as soon as we do that, we press on the brakes. And then in a freeze state, it's like having your foot on the gas and the brakes at the same time. So nothing's happening, but the biological systems in your body have activated both systems. So when we look at stress, we look at the role of cortisol. And our main stress hormones are adrenaline and noradrenaline, but sometimes a stress response lasts way longer than we thought it would. For example, studying for exams, VCE, it's a long, prolonged period of stress. So if we can't maintain the intensity of the fight-flight reactions, a brain-body pathway called the HPA axis is activated. So it puts into motion a slow but longer-lasting chain of reactions and includes the release of cortisol. So when a threat is perceived, the hypothalamus is activated. The hypothalamus stimulates the pituitary gland, which releases ACTH, which is a hormone that travels through the bloodstream and then stimulates the adrenal glands. And the adrenal glands secrete adrenaline and noradrenaline, but also release cortisol, which increases our metabolism and concentration of glucose in the bloodstream. So it just gives us more energy to fight off the stressor for longer. Now, one of the effects is that cortisol does, energize the body, increases energy supplies. It also has an anti-inflammatory effect, so it blocks the activity of white blood cells that contribute to inflammation. So if we're got into an accident and we're really, really stressed, but we're not there yet, we might not feel inflammation or pain in certain parts of our bodies for a while after the adrenaline and the cortisol has worn off, which can be a good thing in immediate times of stress, but obviously has its adverse consequences. And one of those is that the effects of cortisol in the body can be really harmful to our physical and mental health, because excessive amounts over a long time can actually decrease the effectiveness of our immune system and functioning, and leave us more vulnerable to disease. So you spend a whole entire term studying and studying and studying and studying, and you're really stressed and you're really worked up about it, and then you get sick because your immune system isn't at what it was before the stressor was there, and it's compromised as a result. This leads us into the next biological model of stress that we look at, which is Cellier's general adaptation syndrome of alarm, reaction, resistance, and exhaustion. So it's a 3-stage model that considers the role of cortisol in fighting off a stressor. So we have our alarm reaction. So this is when the person first becomes aware of the stressor, the body goes into a temporary state of shock, but then it rebounds during a counter shock period when the sympathetic nervous system is activated. So physiological responses that we see is that our blood pressure, our body temperature drops, and there's a temporary loss of muscle tone. But when that sympathetic nervous system kicks in, we've got increased heart rate, breathing rate, body temperature, and then the glucose is secreted to give us more energy. The systems that are activated in this stage: sympathetic nervous system, parasympathetic nervous system. We have fight, flight, freeze, and we also have SAM. Then we have our resistance stage. So the body's resistance rises above normal. Any unnecessary physiological processes are shut down, and cortisol is released into the bloodstream to further energize the body. So this is where we have fast-acting pain relief, anti-inflammatory agents. The HPA axis, this is when the HPA axis would come in. And now, instead of adrenaline being our main source, we switch to cortisol. But adrenaline is still there, and noradrenaline. And then finally, we have the last stage, which is exhaustion. So after being in a maintained state of stress for a long time, cortisol has been released into the body. Our resources have been depleted. Resistance to stress is really, really weak. The organism becomes more vulnerable to physical and mental disorders. Some of the alarm stage reactions at the start may reappear where everything dropped. And it's characterized by extreme fatigue, increased levels of anxiety and depression, increased onset of physical disorders. HPA axis is still there, and cortisol is the main hormone in the body that's giving us energy, but it's also really undermining our body's ability to do anything else but fight off that stressor, even when we don't have the resources for it. So it's important to know the strengths and limitations of a model like GAS. And one of the, I'll go through one, but there are 3 there for your review. So one of the great things about it is that it identified the biological processes associated with the body stress. So the fact that adrenaline is secreted, and then if we can't keep that up, then cortisol is secreted. So it enables us to have a look at, well, we know that there are different hormones that come in at different stages, and it's perhaps why when we experience eustress and positive stress, we don't get a cold, because we haven't been exposed to cortisol yet. But the weakness of a limitation of the model might be that it only focuses on the biological aspects. And I think that it's important to note that psychological response to stress is very different, and it's very individual. This model assumes that there's like a one size fits all, and that every person who experiences stress, a prolonged period of stress, will experience it in this way, and that might not be necessarily true. So then we move on to a model that helps us look at psychological aspects of how stress is a psychological process, and that's a transactional model of stress and coping. So it's a model of stress that describes and explains individual differences in how people respond to a stressor from a psychological perspective. So this model proposes that stress involves an encounter or an interaction between an individual and their external environment, and that a stress response depends upon the individual's interpretation of the stressor and their ability to cope with it. So if they don't have the resources to cope with a particular stressor, then that's when stress may produce itself or appear, not necessarily just because it is a stressor. The model relies on 2 different types of appraisal or interpretations. Primary appraisals occur when we evaluate or judge the significance of an event. So for example, is this something that I have to deal with? Am I in trouble? Is there any benefit? Does this matter to me? as opposed to the secondary appraisal, which occurs when we evaluate our ability to control or overcome the situation that we find ourselves in. So we evaluate our coping options and resources for dealing with the event. So that's more questions like, what, if anything, can I do? How am I going to deal with this? What can I use to help me? So with the difference between the different types of appraisal, so if we start at the stressor and we do the primary appraisal, we get to a stage where we have to decide, is this something that's completely irrelevant to me? Does it matter to me? Is it benign positive, where perhaps it might cause a stressor, but probably not? Or is it a stressful activity? If we decide that it's a stressful event or thing, if it's a stressor, then we go on to evaluate, well, why is it a stressor? Is there a threat of harm or loss? So how much damage has already occurred because of this stressor? Is there a threat of more harm or loss that can occur in the future? Or does it provide the opportunity for a challenge? Is there something I can gain? Can I grow from this situation? Acknowledging that all three of those outcomes might result in us moving to the secondary appraisal, even if we see it as a positive thing, as a challenge. Now, if we have coping options, so for example, if we have a SAC coming up and we decide, yep, this is a threat, I could fail this SAC, it's not going to go really well for me. But if we get to the secondary appraisal and we think, well, actually, I've got the notes and I've got the PowerPoint slides and I've got the practice questions and I've got my teacher's help to review questions, I might do some exercise this week to help relieve some of the stress. I'll eat well and I'll actually sleep. Well, perhaps I've got the coping resources to cope. Maybe this isn't as much of a stressor as I thought it was going to be. So maybe we don't experience a stress response in that sense. But if we think our coping resources are inadequate, if we don't have the resources, if we haven't got our notes, if we don't know how to answer any of the questions, that might mean that we go into a sense of panic and we actually experience it as a stressor. So the strength of this model is that it actually acknowledges the fact that the experience of stress is not a uniform thing. It is personal, and it does depend on individuals. However, a limitation might be that it's actually quite, as opposed to being able to test hormone levels, levels of cortisol, levels of adrenaline, and in people, it's really difficult to test this model through experimental research because of how subjective stress is and how people experience stress very differently. And that takes us to this concept of coping. So coping is a process which involves cognitive and behavioral efforts to manage specific internal and/or external stresses that are appraised as taxing or exceeding the resources of the person in a stressful situation. So a coping strategy is a method of behavioral or either behavioral or psychological that people use to manage or reduce the stress produced by a stressor. There's this concept of context-specific effectiveness, and it's like this idea that we want to make sure that we want a match or a good fit between the coping strategy that we use and the stressful situation. So we don't want to use a strategy that is not going to help us at all with this stressful situation, but might make us feel good. So this leads us to the concept of approach coping strategies and avoidant. So approach coping strategies involves efforts to confront a stressor and deal directly with its effects, whereas avoidant coping strategies involve efforts that evade a stressor and deal indirectly with its effects. Sometimes approach coping strategies are called problem focused because you're dealing with the issue at hand, whereas avoidant coping strategies might be referred to as emotional focused coping. And you're working to deal with the emotions around the stressor, but not necessarily the stressor itself. And then we look at the role of exercise in helping counter stress reactions, and that includes increasing the efficiency of the cardiovascular system. We experience short-term psychological benefits during or immediately after exercising. We produce chemical changes in the body that improve psychological health, and it actually just provides us with an opportunity to have a time out from the stressor where perhaps we're not actually thinking about the stressor itself. It's a situation and an environment, that it's just away from it. I'm just reading the chat really quickly. Is the SAM reaction and transactional model two different theories? Yep. So SAM reaction is focused on the biological aspects, so things that occur within the body, and it relates to the brain. The description is there, but that's more to do with the biological aspect. We relate that to flight, and fright, whereas the transactional model is about the psychological. So psychological, the way that it's formed, it's got nothing to do with the body and whether we're breathing more shallowly or whether we have more blood around our body. It's purely to do with how we appraise, how we interpret a situation. An example of the difference between harm and loss of the threat. So for example, you're right, it is very subjective. So if harm or loss might be, so if we run with the example of a sack, if the sack is your source of stress and you failed your last sack, and the fact that you failed your last sack meant that you had to resit it, that's a harm or loss that you've experienced in the past, right? So harm or loss experience is damage that's already been done. A threat is damage that might happen in the future. So you could also possibly fail this next sack and have to resit it again. So that they don't necessarily have to be different things. It's just that one has happened in the past. So that might be where you've interpreted the possibility for this to happen again, and then one's happening in the future. Hopefully that helped. Okay. There's this. Yes.
Did you want to also, just given you're in this section, yep. Tara also asked a question about how long does it take for cortisol to come into effect?
Okay, so there's no time frame, but the idea is that you've used up your body's adrenaline. So for example, so there's no specific time frame, but the idea is that if you've been on adrenaline for a really long time, then that's when cortisol will come in. So perhaps you might experience the stressor of school for an entire, a really hard term at school. But if you've stopped and started, so if you've had a bit of a stressful period, but then it stopped and your body stopped producing adrenaline, it doesn't mean that when the stress happens again, you'll automatically go into cortisol. You might go back into a state of adrenaline. And if that state now prolongs, then that's when the cortisol might come in. So there's no time frame, but the idea is that it's when the body can no longer sustain the effects of adrenaline and noradrenaline, because they're meant to be temporary. If there's a longer lasting existence of a stressor in the environment, that's when cortisol comes in. Hopefully that.
The research I'm looking at the moment says approximately 15 minutes after the onset of stress, and can last up to several hours.
Okay, all that. We never did a number in, hopefully you won't have to give a number in your exams, but I never did. So hopefully, Thanks, Tim.
No problem.
Can you have a cold from stress? Yeah, you can. So you can develop a cold, a flu. You can be really weak, fatigued, unable to get out of bed sort of thing. So that's that covers it. Okay, so this example from one of the exams is one of, I hated it last semester, but it's one of my favorite questions, last year, sorry, but it's one of my favorite questions now. This is an example of an extended response which looks at the effects of stress and the interactions between, so just a question. So we're discussing theories and models of stress or coping that are relevant to this scenario. I'll quickly read it out and then I'll just quickly go through what a sample response would include, and also some tips on how to approach extended questions. So Gita is a 22-year-old student in her final year of university. She arrived in Australia when she was 12 years old. She's from a non-English speaking background and is the first female in her family to attend university. She's generally been able to manage her parents' expectations and academic demands of part-time work and the usual daily irritants that have come her way. When she lost her part-time job at the beginning of semester 1, she experienced initial shock, but quickly tackled this problem by drawing on her family and friendship network. End of semester 1, her first relationship breakup proved more challenging because she found her usual supports were not enough. She used meditation and dancing classes, but she developed a cold after the breakup, still managed to stay on top of things. Semester 2, I'm just skimming through this. She felt exhausted and overwhelmed by the situation, but decided to keep the problem to herself. Towards the end of semester 2, she developed insomnia and headaches and finally visited her family doctor. Doctor explained that these symptoms were stress-related and referred her to a psychologist. The psychologist was able to help Gita view her situation differently and assist her with realizing that it was a temporary problem and that it would be resolved once she finished university and started full-time work. So extended response questions are really a lot in psych simply because they require you to know a lot and bring things from different topics. There's this concept of buying time that I really like around exams. Not sure if you've heard it before, but it's this idea that there's a minute and a half per mark for your exams in psych. And what I did to help me prepare, so extended response questions, I found it's not that the longer they are, the better they are. The longer they are, the more information you're actually able to hold and the more connections you're able to draw between the theory and the example that they give you. Personally, I found that 15 minutes wasn't enough for me to do that. So I needed half an hour. So what that meant was that I had to buy time from my other questions to make time for my extended response at the end. And that meant that I practiced doing my multiple choice questions. I would not be spending 1.5 marks per minute on those. There are 50 to 60, I think, something like that in the exam. I did multiple choice questions until I got it to half the time. And that meant that I could have, and with accuracy as well. So it's not like I'm winging them. You try to do it to the best of your abilities, and you learn that a lot of the multiple choice questions are quite similar across the years in that the content they cover is similar, but also the way that they phrase the questions is similar. And it's just about being able to read and find key terms and definitions and things like that. That means that you have more time for your extended response. And why that's important is I think that you should always plan your extended response. And by that, it's not a detailed thing. So if we go back to the question, things that you can pick up from there is that they've mentioned words like exhausted. They've mentioned that she's developed insomnia and headache. So in my head, I've gone, okay, I'm going to have to use the GAS model. They've mentioned she's from a non-English speaking background and that she had a breakup. So that signals to me that, okay, a culture of stress might be a source of stress. Life events might be a source of stress. And then looking at the transactional model of stress, you think, well, she didn't appraise it to be a stressor at the start because she didn't see that she didn't feel like she'd experience maybe harm or threat because of it. But then at the end, the psychologist says that now she's able to view things differently. So the appraisal has changed. We also look at coping and we think, oh, well, she's tried to use meditation and dance classes to help her refocus. Is this an example of avoidance or approach-based coping? So you're using the content that you know and you're applying it to the scenario. And that's why I think you need a plan, because when you've got lots of different theories and models, it's easy to get a bit muddled, especially in your exam. So having like a brief, even if it's like a couple of words where you're like, GAS, stage 1, these are examples from the scenario. Stage 2, these are the examples. Avoidant coping, this is what I'll say. It can mean absolutely nothing to anyone else but you, but it helps you have something to go back to during the exam so you're not flustered. I would recommend that you break up and section your writing, and usually they give it to you. So I had something called sources of stress, and then I had biological responses, and then I had psychological responses. And sectioning it out just makes it, number one, look neater. Number one, makes it a lot easier to read. And number two, just indicates to your marker that you know that these are the different things that the question is asking of you. And then the really important thing is also to try and be as specific as possible and link to the theories and examples. If you can't find evidence of a theory in the scenario, don't bring it in for the sake of bringing it in because you want something else to talk about, because they're gonna try to mark you on your ability to link theories to the examples that they've given you. So a brief example of what that might look like in terms of just a plan. And also they mark extended responses holistically. So they're not looking for, there's no 2 marks here and 3 marks there. It's more judged on a whole, which means that you can have a wide range of different answers that they will definitely accept. So it's not too mean in that sense either. So for example, we can say that daily pressures, so Gita's parents' expectations, her academic demands, her part-time work. A cultural distress might be that she arrived in Australia when she was 12. She's from a non-English speaking background. Why might that be a source of stress? And this is from the examiner's report, so it's exactly what they want you to do. So when Gita lost her part-time job, she experienced initial shock but quickly tackled this. So we're saying, well, there was an alarm reaction stage where she experienced an initial shock. We know that because everything crashes down before it comes back again in the counter shock stage. Physiological changes, you can say that we release adrenaline and cortisol. And then after Gita's relationship breakup, she developed a cold. So we can then say that that's evidence of resistance, adaptive stage. The insomnia and headaches comes from the role of cortisol, but the detrimental role of cortisol in weakening the immune response. And then you could also talk about, so I remember when I did this question, I had a section that was about the psychological responses in terms of, you don't have to be too in depth, but even saying, just mentioning the transactional model and saying she reappraised the situation and realized that now that she views the situation differently, it means that things that were once very stressful are no longer stressful to her, or she feels like she can cope with them. Great, so that's the end of area study 1. But I would definitely recommend, if you haven't had a go at that question yet, in your practice, in your prep for exam, have a go at it. Even if you've got all your notes open, try to practice that structure of trying to, break up your response and your answer. So, oh my God, I talk a lot. Unit 3, AOS 2, looks at learning and memory. And we look at this concept of neuroplasticity, and that's the ability of the brain's neural structural function to change over time by experience. And the term synaptic plasticity refers to the ability of the synapses that exist between the neurons to change over time through either becoming stronger or weaker. So Donald Hebb proposed that learning results in the creation of cell assemblies, which are interconnected groups of networks that form networks or pathways. So when neurotransmitters are repeatedly sent across the synaptic gap, neurons are repeatedly activated at the same time. So when a presynaptic and a postsynaptic neuron are activated at the same time, the structure of the synapse at that meeting point is strengthened because they keep firing at the same time. When the synaptic connection is strengthened, it makes it more likely that they will fire again and again, and the signals are going to be a lot stronger. However, in a similar fashion, if those synaptic connections aren't strengthened and aren't rehearsed and used, the connections are going to be weakened. So for example, I learnt Chinese from Prep Tier 11. And so while I was learning the language, my synaptic connections for the language were really, really strong. I dropped Chinese in Year 11. I can tell you that through disuse, I know a lot less. So languages is a really good example to use, because if you don't keep practicing and keep firing those neural pathways, they'll tend to weaken, and over time you won't remember any of it. So then we have these concepts that supplement this, which is long-term potentiation, which refers to long-lasting strengthening of synaptic connections, resulting in enhanced or more effective synaptic transmission. So that's the idea that the more you use a neural pathway, the more those presynaptic and postsynaptic neurons fire at the same time, the more likely that you're going to be able to remember it and use those pathways. And it decreases the likelihood that you're going to forget something that you've learned. However, in the opposite fashion, long-term depression is a long-lasting decrease in the strength of synaptic transmission, and that can result from a lack of stimulation of the pre and postsynaptic neurons, or prolonged low-level stimulation. So if I only use a few phrases of Chinese every now and again, I might remember only those few phrases, but everything else for the language is going to go because it's a sustained level of sustained low-level stimulation. So we also look at the role of neurohormones. So we've talked about neurotransmitters. So like neurotransmitters, neurohormones are chemical messages that are manufactured by neurons and released from the axon terminals. Unlike neurotransmitters, they're not released into the synaptic gap though. They're released into tiny capillaries, so like tiny blood vessels, where they're absorbed into the bloodstream and carried to target neurons and other cells, which takes a little bit longer than neurotransmitters. But the effects of neurohormones can be on distant cells or organs sometime after their secretion, whereas neurotransmitters are released locally at a synapse, and their effects on adjacent postsynaptic neurons are really fast acting. So we talked about glutamate earlier, but we now talk about glutamate in relation to its role in learning and memory. So it actually promotes the growth and strengthening of synaptic connections between neurons, within a neural pathway that subsequently represents the memory of what has been learned. So the often that glutamate can excite adjacent neurons, the more it contributes to long-term potentiation, and vice versa for long-term depression. So we look at this process, what is known as consolidation, and it's a biological process of making a newly formed memory stable and enduring after learning new incoming information is temporarily stored in short-term memory before it's transferred to long-term memory. So it's thought that it takes around half an hour, but it's this idea that when something is new, it's really impressionable, and if we don't transfer it to long-term memory, then we can lose it really quickly. So the hippocampus plays a significant role in the consolidation of our memories, and it's involved in the formation of encoding new declarative explicit memories, semantic or episodic, but not directly in the formation or retrieval of implicit procedural memories. So when a memory is retrieved, so if we've consolidated a memory but we bring it back into conscious awareness into our short-term memory for use, then it goes through what is known as a process of reconsolidation, where perhaps we might add information to it before it's consolidated back into long-term memory. We acknowledge the role of the amygdala in encoding and storage of memories that have a significant emotional aspect. And this is sort of supplemented by the role of adrenaline, because adrenaline can enhance the consolidation of long-term memories of emotionally arousing experiences and is a neural hormone. So it means that these types of events are more likely to be well remembered, but not necessarily more accurately. So when released during heightened arousal, adrenaline induces the release of noradrenaline into the amygdala. The presence of noradrenaline during consolidation may then activate the amygdala to signal the nearby hippocampus that details of the relevant experience are significant and its long-term storage should be strengthened. So for example, I have a friend who's absolutely terrified of dogs. He's got a really bad first experience of dogs. It was an emotionally arousing experience. So it means that her perception of the memory, it's not that it's invalid or wrong, but it's heightened to the extent that it might be over-exaggerated. So that's just one of the ways that memory can be well remembered. She remembers the incident very well, but it's not necessarily the way that it occurred precisely because of the role that our emotions have in that. So then we look at learning, and that's commonly defined as the relatively permanent change in behaviour that occurs as a result of experience. And then we look at conditioning, and conditioning is the process of learning associations between a stimulus in the environment and a behavioural response. So we look at two different types of conditioning, so classical and operant, and then we also look at observational learning and how that takes theories from the different types of conditioning and implements it in a different type of learning. So classical conditioning refers to a type of learning that occurs through the repeated association of two or more stimuli. So the response that is automatically produced by one stimulus becomes associated with another response that would not normally produce that response. So a stimulus is any object or event that elicits or produces a response from an organism, and then a response is a reaction by an organism to the stimulus. So we look at the different elements of classical conditioning that lead to a response being learnt. So we've got the neutral stimulus, which is any stimulus that does not normally produce a predictable response. In the case of Pavlov's dogs, that would have been the bell. The bell doesn't normally produce the response of salivation. The unconditioned stimulus is any stimulus that consistently produces a particular naturally occurring automatic response. In Pavlov's dog's experiment, that would have been the food. Food consistently produces the response of salivation in dogs. The unconditioned response is the response that occurs automatically when the UCS is present, and it's a reflexive involuntary response that is predictably caused by the UCS. So that's salivation. Now, the conditioned stimulus is a stimulus that is neutral at the start of conditioning, but eventually elicits a very similar response to that caused by the UCS. So we pair the food and the bell together, and after multiple trials, the bell becomes the conditioned stimulus because, the bell becomes the conditioned stimulus. And then the conditioned response is a learned response that is produced by the CS, so that's salivation. Whenever you're looking at classical conditioning, the neutral stimulus and the conditioned stimulus are going to be the same thing. In both cases, it's the bell. The conditioned response and the unconditioned response are always going to be the same thing. salivation. The only thing that is going to be different is what you're pairing it with to produce the response. So a trial is each paired presentation of the neutral stimulus with the unconditioned stimulus. And the term acquisition is used to describe the overall process during which an organism learns to associate two events, the neutral stimulus and the unconditioned stimulus, until the neutral stimulus alone has become a conditioned stimulus that produces the conditioned response. We just went through this, but that's the sort of, so before conditioning, this is what happens, during and after. Cool. So there are various characteristics of conditioning that we look at. One of them is stimulus generalization, and that's the tendency for another stimulus that is similar to the original CS to produce a response that is similar, but not necessarily identical to the CR. So for example, if we're looking at the bell as our original conditioned stimulus, it might be that a gong, or it might be that something that might sound similar, but it's not necessarily the same thing. It might also produce salivation in dogs. Whereas stimulus discrimination occurs when a person or animal responds only to the CS and not to any other stimuli that is similar to the CS. So this would take the opposite approach and say, no, the organism would only respond to the bell. It would not respond to the gong because it is not what the original stimulus was. We look at extinction, and that's the gradual decrease in the strength or rate of a conditioned response that occurs when the UCS is no longer present. It might fade over time or disappear altogether. And then we look at spontaneous recovery, and that's the reappearance of a CR when the CS is presented following a rest period after the CR appears to have been distinguished. So it doesn't always occur, and when it does occur, the response tends to be weaker than it was at the start when the conditioning process was at its strongest. Then we look at operant conditioning. And operant conditioning is a type of learning where consequences of behaviour determine the likelihood that it will be performed again in the future. And we look at a three-phase model. So we say that there's an antecedent, which is a stimulus that precedes a specific behaviour, signals the probable cause for the behaviour and influences the occurrence of the behaviour. We'll say that there's a behaviour that's a voluntary action that occurs in the presence of the antecedent, and the consequences is the environmental event that occurs immediately after the behaviour and has an event on the occurrence of the behaviour. So our consequences come in a few different types. So we've got reinforcement or punishment. So reinforcement occurs when a stimulus strengthens or increases the frequency or likelihood of a response that it follows. So positive reinforcement involves giving or applying a positive reinforcer after the desired response has been made. So for example, you ask your little sibling to pick up something and they do it, so you give them a lolly. So you reward them, and that increases the likelihood that they're going to pick up their toys in the future. Whereas negative reinforcement involves the removal of an unpleasant stimulus, which has the effect of increasing the likelihood of a response being repeated, which also strengthens the response. So for example, if your sibling has a curfew, but they do something that your parents ask, you remove the curfew, which is an unpleasant stimulus. We don't like curfews, as a reward for doing the response. So the sibling learns that if you do the response and if you do what parents ask, then curfew might be something that is removed so they have more freedom. Then we look at punishment, and that's the delivery of an unpleasant consequence following a response, or the removal of a pleasant consequence following a response. So positive punishment involves the presentation of something. So for example, if you don't do your homework at school, schools might give you a detention. So they're giving you something that aims to decrease the likelihood that you're not going to do your homework. Whereas negative punishment involves the removal of a loss of a desired stimulus. So for example, you haven't done your homework and your parents decide that they're going to remove the Xbox in order to decrease the likelihood that you're not going to do your homework in the future. Now, linked to the idea of negative punishment is this concept of response cost, and it involves the involuntary removal of any valued stimulus, whether or not it causes the behaviour. So, for example, if you get a speeding fine and your money is taken away from you, even though it's not what caused you to speed. So it's not that we're removing driving privileges away from you, we're removing money. Sorry? Never mind. And then similar to classical conditioning, We have stimulus generalization, which occurs when the correct response is made to another stimulus that is similar but not necessarily identical to the stimulus that was presented. So I think I think it was Skinner's pigeons that we conditioned them with lights, and it might be that you are conditioned with a green light and you receive a pellet of food, but you might also respond to a red light, even though that's not what you were conditioned with, but it might be similar enough. Whereas stimulus discrimination occurs when you only respond, you only make the correct response when it was the original stimulus that you learned with. So it might be that you only respond to the red light and not the green light because the red light is what you originally learned. Extinction, we talk about the gradual decrease in the strength or rate of a conditioned response. And then spontaneous recovery, again, we're looking at after a period of apparent extinction of a conditioned response, the organism might again show the responses in absence of any reinforcement. Then we move on to the concept of observational learning, which occurs when someone uses observation of a model's actions and their consequences, and the consequences of those actions to guide their future actions. So we talk about it in this, we use vicarious conditioning. So it's where the individual watches a model's behavior either being reinforced or punished, and then subsequently we behave in the same way, or in a modified way, or refrain from behavior as a result of what we have observed. So vicarious reinforcement, it increases the likelihood that we will behave in a similar way to the model if they're being reinforced, whereas vicarious punishment occurs when the likelihood of an observer performing a particular behavior decreases after seeing a model's behavior being punished. Now, there are lots of 5 processes that are required in this order in order for observational learning to occur. So we talk about attention. So we have to make sure that we're actually paying attention to the model's behavior in order to not only see the model's behavior, but also the consequences of that behavior. So retention, we want to be able to remember the model's behavior and store it in a mental representation of what has been observed. We want to have the ability to reproduce. So once we see it, we might attempt to reproduce or imitate what has been observed, but we have to have the ability to put it into practice. Motivation, so we might want the desire and want to reproduce what has been observed, but we also, and then in terms of reinforcement, it influences the motivation to reproduce an object. So for example, we might want to learn a bike because we want to learn a bike, but we might also want to learn how to ride a bike because we want to be able to have the freedom of riding a bike. But if we see that mum's been really nice to my older brother who knows how to ride a bike, I want mum to be nice to me as well. Hence, I will learn to ride a bike. So motivation and reinforcement tend to complement each other as well. Then we look at, so Albert Bandura designed and undertook this experiment with children to look at the effects of observational learning. And he designed a study where he had 3 conditions. So there was a video, and there was an aggressive model who was like punching and spanking a doll, like a Bobo doll. And they had 3 different conditions. So they had one condition where after the model did that, the aggressive model was rewarded with lollies, soft drink, and praise by another adult. So that's our reinforcement. The aggressive model in condition 2 was punished. And then in condition 3, there were no consequences. So the model was neither rewarded or punished. And what we saw from that was that the consequences that we have for the adult model did make a difference to how the children acted and how they behaved. So the children who saw the aggressive model being reinforced or experiencing no consequences imitated aggressive behavior more than the children who watched the aggressive behavior be punished. And when they were offered a reward for imitating the model's behavior, even those who had seen the behavior being punished behaved more aggressively. So after that, they put the children in a room with a Bobo doll and they observed what they did, and these are the results that they found. So the conclusions is that observational learning can sometimes occur just by viewing a model, even if the model is neither reinforced nor punished. And the results indicated that probably all the children learned the model's behavior, regardless of whether they observed the model being reinforced, punished, or experiencing no consequences. And the provision of an incentive really made a difference in terms of some of the children just didn't behave at all until they were provided with an incentive to do so. In terms of classical conditioning, we look at the Little Albert experiment. And a conditioned emotional response is an emotional reaction such as fear or anger in response to a specific stimulus. So it's observed when the autonomic nervous system produces a reaction to a stimulus that didn't previously trigger that reaction. So the little Albert experiment involved, Watson, he intentionally conditioned an emotional response in little Albert, who was the 11-month-old son of a woman who lives on campus. Now, he was chosen because he wasn't frightened or aroused easily, and he rarely cried. So there was that element of perhaps that's not going to act as an extraneous or confounding variable in our experiment. And they exposed him to a white rat, and he was placed on a mattress, and he played with it. Initially, he showed no fear. Watson then struck a hammer, producing a very loud noise, so that's the UCS, that caused Albert to become alarmed and frightened, our UCR. Eventually, he burst out into a crying fit every time he went to play, and every time he went to play, the hammer was struck. So we associated the white rat with the hammer that produced a really loud noise, which produced the fear response. After several pairings, he now showed distinct fear of the rat. So that's the CR, and the conditioned stimulus now has become the rat, and it's replaced the loud noise. So we look at this in terms of ethical implications, because there are various things that we want to consider when we conduct experimental research, and three of the things just relevant to this is this idea of withdrawal rights. So we want to make sure that if we're including someone in a research study, an experimental research study, one that might have negative implications for the participants, we want to make sure that they are very, very aware that they are able to withdraw at any stage. That's just an ethical implication for psychological research. However, in this case, it wasn't clear whether any allowance was made for the withdrawal rights to be exercised. And it wasn't clear if this option was explained to Albert's mother. And if it wasn't explained, that would be a clear breach of ethical standards. We also talk about this concept of beneficence, and this idea that we want to make sure that the harms don't, we don't want to be, we want to make sure there's a benefit. We want to make sure that the harms don't outweigh the benefits of our study. However, we want to make sure, like in this experiment, it looked like Albert I don't think they ever extinguished the response. So that's not very good for the psychological development of an 11-month-old. Also, we look at the concept of informed consent and making sure that little Albert's mother was fully aware of how they were going to get this conditioned response, and willingly and voluntarily causing, producing fear in an infant. And there are no known records of informed consent either. So that would be some things that would make us question the ethical standards in this experiment. Beautiful. So we're moving on to memory. So memory is often defined as the processing, storage, and retrieval of information acquired through learning. And there are three fundamental processes. So we've got encoding, where we convert information into a form that can be neurologically represented and stored in memory. We look at storage, which is how we retain encoded information over time, and retrieval, and that's the recovery of stored information and bringing it into conscious awareness for use. We look at the Atkins and Shiffrin multi-store model of memory, and it explains memory as consisting of three different stores. So sensory memory, short-term memory, and long-term memory. And we look at it as being a byproduct of structural features. So they're the permanent inbuilt fixed features of memory that don't vary from one person to another. For example, we all have, so through this model, argues that we all have sensory, short-term, and long-term memory, right? So they're things that don't change. Whereas the control processes refer to things that are selected and used by each individual and may vary in different situations. So for example, how much attention we pay to things, how we choose to retain information, how do we study? Do we study in a way where we're reading our notes, or do we make cue cards and create mnemonics and encode and rehearse information in a more elaborative way that enables us to hold on to information for a little bit longer? So they're the things that we can change and control. So in terms of sensory memory, it's the entry point of memory. We talk about it in terms of we think there's an unlimited capacity. So there's a lot of things that we can become aware of, but we pick and choose what we want to focus on. So we've got iconic memory, which is used to describe visual sensory memory for incoming visual information. And that generally lasts for about 0.2 to 0.4 seconds. And echoic memory, which is used to describe the auditory sensory memory for incoming auditory information. And that generally lasts for 3 to 4 seconds. That sort of explains why sometimes you hear someone say something and you go to say pardon, but by the time you've said pardon, you've actually processed what it is. So it takes a little bit longer. And then we look at short-term memory, and it's a memory system with a limited storage capacity as opposed to sensory memory where we can take in everything, in which information is stored for a relatively short period of time unless it's retrieved or engaged with in some way. So we say that there's a duration between 18 to 30 seconds. It might be a lot, 12 to 30 seconds, but that's usually the range that we work with. And we say that the capacity is between 5 and 9 items, or 7 plus or minus 2 bits or chunks of information. Now, so when we're using short-term memory, we can only have new items in by chucking other items out. So if you try to remember a phone number individually, you usually tend to stop after, you would stop after the 9th item and then go again. Phone numbers aren't the best example, but you stop when you're typing your notes, you stop for a little bit and then you come back because there are only so many things that your short-term memory can take. However, we can increase the capacity of short-term memory by using chunking. So if we go back to the phone number example, if we tend to group the phone numbers in groups of 4 and 4, 4 and 3 and 3, or something like that. And that just means that instead of each number being an individual chunk, the group becomes a chunk. And that's how we can perhaps have more information in our short-term memory to combat the fact that we have a very limited capacity. Then we look at long-term memory, and long-term memory arguably stores a potentially unlimited amount of information for a very long time, possibly permanently. We have 2 different types of long-term memory. So explicit or declarative memory involves memory that occurs when information can be consciously or intentionally retrieved and stated. So episodic memory, and then we've got 2 types of explicit. So episodic memory is a long-term explicit memory of personally experienced events. So for example, your first day at school, whereas semantic memory is long-term explicit memory of facts and knowledge about the world. So for example, who our current Prime Minister is. Implicit memory involves memory that does not require conscious or intentional retrieval. And then the 2 types are procedural memory, so the memory of motor skills and actions that have been learned previously. So for example, I mean, I do, but we don't teach ourselves how to walk every time or ride a bike. Those are things that are procedural, and over time it just happens. We don't have to think about it. And then classically conditioned memory. So conditioned responses to conditioned stimuli acquired through classical conditioning. So conditioned responses involving fear or anxiety. So when we're looking at how long-term memory is stored, there are different brain areas that play different roles. So the cerebral cortex, which is like the thin outer layer across all of, I'm pointing at my brain like it's going to mean something, like all over our brain. So different areas. So generally, long-term explicit semantic and episodic memories are widely distributed through the cortex, and their permanent storage tends to be in areas where the relevant information was first processed. The hippocampus, so we've talked about it in terms of its role in the consolidation of new semantic and episodic memories, but it's not involved in the formation of implicit, procedural, or classically conditioned memories. It's believed that it doesn't store any memories itself, but just transfers them to the cerebral cortex for long-term storage. And then through its interactions with the amygdala, it also plays in the role of consolidating and the formation, of emotional memories, particularly with the explicit component of an emotional event. Now we say the amygdala, best known for its role of processing and regulating emotional reactions, but again, it's responsible for the emotional component of an episodic, explicit episodic memory. And then the cerebellum, so it's located at the base of the brain. It's responsible for things like balance, coordination, and movement, but in terms of memory, it's directly involved in the encoding and temporary storage of implicit procedural memories, so things like riding a bike. And it does form implicit memories of simple reflexes acquired through classical conditioning. So cerebellum's more implicit, cerebral cortex, hippocampus, and amygdala all play a role in how we remember episodic and semantic memories long term. Then we look at different ways of retrieving memories. So one of the ways is through recall. So that's reproducing the information that's in our memory. So free recall involves reproducing as much information as possible in any order without the use of any specific cue. Serial recall involves producing information in the order in which it was learned or in a specific order in which you've instructed. And then cued recall involves the use of specific prompts to aid retrieval and therefore reproduction of the required information. So for example, if we run with the Prime Minister example, so free recall might be name as many Prime Ministers of Australia as you can remember. Serial recall might be going from current backwards, name the Prime Ministers in that order. Cued recall might be that I give you the initials of each Prime Minister and I say, who would this be? And I've given you a cue or prompt to aid the retrieval. Recognition, on the other hand, involves identifying the original learned information. So the presence of the correct information acts as a cue for its retrieval from memory. So when we think of multiple choice questions in exams, that's exactly what they are. The correct information is there. You just have to discount other options according to what you've learned and what's already in your memory. We talk about relearning as well. So learning information, again, that has been previously been learned and was therefore, it's meant to say stored in long-term memory. And then in terms of the different types of retrieval methods, we say that they have different sensitivities, and that relates to how much information are you likely to produce from using a certain retrieval method. So we say that recall tends to be the least sensitive measure of retention because it's a lot harder to reproduce information free without any sort of prompt or help. We say that relearning tends to be the most sensitive because you're actually learning the information all over again. So it's going to be a lot fresher, and also the synaptic connections are going to be stronger because you're revisiting neural pathways that you've already created. And we say that recognition tends to be somewhere in the middle. So it's not as sensitive as relearning because you haven't freshly relearned all the information, but it's easier than recall because the information is there, you just have to find it. Then we look at the effects of brain trauma. So brain trauma is an umbrella term that relates to any brain injury that is acquired after birth and impairs the normal functioning of the brain, either permanently or temporarily. So we talk about, we touched on like Parkinson's, how it's a neurodegenerative disease. And what that means is that it's a disorder characterized by the progressive decline in the structure, activity, and function of the brain over time. Amnesia refers to the loss of memory that is inconsistent with ordinary forgetting. So we can't really, it's not like forgetting someone's name. We have two different types of amnesia. So we say that anterior grade amnesia is a loss of memory for information or events that occur after the trauma that has caused the amnesia. So people with anterior grade amnesia lose the ability to form or store new long-term memories. Whereas retrograde amnesia is the memory loss for information or events formed before the trauma that causes the amnesia. So anterior grade, old memories are retained, new memories can't be formed. Retrograde, old memories are lost, new memories can be formed. So we look at the effects of brain trauma on different areas of the brain, We look at the case study of Henry Molaison, who had been suffering from really bad seizures, and the seizures were located in the medial temporal lobe, so where the hippocampus is, and the amygdala. And as such, they decided to remove a significant proportion of the medial temporal lobes, and that had an effect on his ability to form new memories and the way that the different structures of the brain works. And it sort of told us a little bit more about the role of different brain structures. So we know that the hippocampus doesn't have to do a lot with procedural memories, but we know it's got a role in the formation of semantic and episodic memories. So if we remove a section of the hippocampus, that means that it's likely to impair the consolidation process, which sort of accounts for why if you can't move a short-term memory, so if you tell me your name, that's in my short-term memory, if I can't consolidate that because my hippocampus is damaged, then that means I can never transfer it to my long-term memory. And that's why we say, most likely that's why Henry Molaison was incapable of forming new long-term semantic or episodic memories. We look at the amygdala. and we acknowledge that it's got a role in the formation of emotional memories, but the removal of the amygdala might have consequences such as you might not be able to recognize facial expressions, we might have problems with emotional memories, and we might not be able to require a condition for your response. In terms of the cerebral cortex, Henry Molaison's was kept relatively intact. And that's why we can say that perhaps that's why you can retain your old memories, because they'd already been formed within well-established neural connections. However, damage to cortical areas that had originally processed the information for a memory can disrupt its storage and retrieval. So for example, if we have damage to our occipital lobe and I meet someone new and I see their face, I might have trouble with like the visual component of that explicit memory. So I might not be able to remember what you look like, but I still remember that there's an element of that memory there. And then we look at the cerebellum and we say that, well, we know that it's got a role in our implicit memories, but also if you remove either of the spheres of the cerebellum, then it might result in severely impaired spatial learning and memory. Then we look at Alzheimer's disease, and that's a type of dementia that's characterized by the gradual widespread degeneration of brain neurons, progressively causing memory decline, deterioration of cognitive and social skills, and personality changes. So when we look at the brain damage that's associated with Alzheimer's disease, postmortems of brains expose the brain with cortical and subcortical areas that look shriveled and shrunken due to widespread death of neurons in the medial temporal lobe area. So that literally means that the brain is smaller. So there are less neurons in the brain, less connections that are being made. So the brain is a lot smaller than what you would see in a healthy brain or a brain without Alzheimer's disease. We can find abnormal structures, including plaques, which are fragments of a protein that the body produces, and they're normally broken down. But in the brain of someone with Alzheimer's disease, they tend to form clumps so hard insoluble plaques outside and around the neurons, and thus they impair synapses and inhibit communication between neurons. And we also look at tau, which accumulates in an insoluble form. And deposits a type of structure called neurofibrillary tangles, which inhibits the transport of essential substances through the neuron. So essentially what happens is there are insoluble plaques and tau in the brain, and what happens is it blocks neurotransmitters from being able to get the things that they need to survive. So when they die, that's why we have interference between neuron communication. And then we also look at levels of acetylcholine, which are also greatly reduced in people with Alzheimer's. And while there's no cure for Alzheimer's, the use of medications that boost levels of acetylcholine seem to slow the rate of the development, but it doesn't prevent it or anything like that. Then we look at rehearsal, and so how people can actually the different things that affect people's ability to remember information. So there are two types of rehearsal. So rehearsal is a process where we try to manipulate information to either keep it in our short-term memory or transfer it to long-term memory so it's stored properly or effectively or to the best ability. So we have maintenance rehearsal, which involves repeating the information being remembered over and over again so that it can be retained in short-term memory. So this is equivalent to if you were to just read your notes passively again and again and again and again, that might keep it in your short-term memory, but it doesn't do much for trying to, number one, move it to the long-term memory, but also if you are maintaining information in your short-term memory, you're using up your 5 to 9 chunks of information. So it makes it really difficult for other information to come in because you're preoccupied with remembering this one thing. That's where elaborative rehearsal comes in. And we talk about how perhaps learning information and improving long-term memory can be more effective if we link new information in meaningful ways with either other new information or information already stored in long-term memory to aid in its storage or retrieval from long-term memory. So for example, if we go back to the sympathetic nervous system and the parasympathetic nervous system, a memory that I have already in my brain is that for some people, snakes are scary. And that's why I can link that concept to, that's why people might freak out, and hence it activates the fight and flight response. Old information, new information. Similarly, the process of the effects of the parasympathetic nervous system, I understand from previous knowledge that parachute, if you think of it, it's like air flowing through it, it's kind of calming. Okay, that means that the parasympathetic nervous system will return the body to a state of homeostasis. So using things you already know or linking things with new information actually helps us encode information in a way that enables a deeper level of information processing that's not as shallow as just repeating information over and over again. Then we talk about forgetting, and it's the actual inability to access or recover information previously stored in memory. We talk about retrieval cues and how they are they assist us in the process of locating and recovering information stored in memory. So we talk about context-dependent cues that are environmental cues in a specific situation where a memory was formed that acts as a retrieval cue to help access the memories formed in that context. So for example, I can't walk past Edinburgh Gardens because it was close to the place where I did my exams, and every time I go to Eddie's, all I can think about is my exam week. So that's a context dependent cue. There's a cues in the environment, whereas a state dependent cue is associated with an individual's internal physiological and psychological state at the time a memory was formed, and it helps us access those memories. So now that I'm in uni, whenever I have to study for, or like the rush of like writing an essay or having an assignment or doing exams, also reminds me of the time of year 12 and doing exams, but not because of my context, because of my internal state. Then we talk about the finding of the serial position effect, that at free recall is better for items at the end and the beginning of a list than for items in the middle of a list. So the primacy effect describes superior recall for items at the beginning of a list, and the recency effect describes superior recall for items at the end of a list. Now, the reasoning behind this is that the first few items in a list are remembered well, probably because they receive more attention and rehearsal than other items, and they're transferred to your long-term memory. The items at the end of the list are still in your short-term memory. The items in the middle of the list haven't been rehearsed enough that they can transfer to your long-term memory, and they've been kicked out of your short-term memory by the items at the end of the list. So that's why we consequently have better retention for items at the start and the end of the list. Then we look at memory reconstruction and Loftus's research into the fallibility of eyewitness testimony and memory. So memory reconstruction generally involves combining stored information with other available information to form what is believed to be a more coherent, complete, or accurate memory. So Lotus has found that eyewitness testimony is not always accurate because eyewitnesses can reconstruct their memories, and their reconstructed memories can be manipulated by leading questions that contain misleading information. So they might be phrased in a way as to suggest what answer is desired, or lead to having an answer, lead to the information provided in the question to change the way that you would respond had that information not been there. So Loftus proposed that any model of memory should include the process of reconstruction that occurs when information is integrated into the original memory. So her experiment looked at a group of university students, and they were shown a video of a car having an accident. And they had different groups, and for each group, they used a different verb to ask the students about how fast they thought the car was going. And the way that it was manipulated was that, for example, one group might have been asked how fast was the car going when it contacted the wall or whatever it was, whereas another group was asked, and there were varying degrees in the middle, but how fast was the car going when it smashed into the wall, hypothetically. So what they found was that the word that was used, the more intense verbs, produced higher miles per hour that the participants assumed that the car was going, and the use of less intense verbs actually resulted in lower speed. So that sort of indicated that new information that's acquired after the original experience, after they'd seen the video, becomes integrated with information in the original memory of how they thought they saw that video. and that results in recall of a constructed or altered version of the original memory. A way that this plays out in everyday life might be, so eyewitness testimony, and if you have a lineup of potential people that might have been the person that committed a crime, and it's your responsibility to pick one, the way that lawyers or officers might use their language has the ability to affect how or who you would pick. So for example, if they said, you mentioned something about height, or are you sure, like information that that is given to us has the ability to be integrated into the memories that we think we have. Okay, so I've included, just for time-wise, we're probably not going to be able to go into this too in-depth, but it is in the slides. So it's an example from an exam. And in the next slide, I've just broken down how I would go about answering that question. For questions that are anywhere between 2 and 6 marks, I would really recommend just in your head having a little bit of, a mark would come from here, a mark would come from there. A great thing in psych is that the task words really help you identify how much work you need to do. So an identify, and explain, a distinguish, as opposed to a discuss or a justify, used to tell me that there are specific things that I need to pinpoint for the first 3, whereas a discuss or a justify might require me to just think a little bit more, and it's not going to be factual knowledge that I have at the tip of my tongue, sort of thing. So please feel free to go through that. But I wanted to quickly go through, so this was my question from my exam last year, the extended response. And again, I think extended responses tend to be really difficult just in terms of you don't know what to include. And I wanted to include this one just because, as opposed to the first extended response that I showed you and how much information you had to work with, I remember walking into the exam and looking at that and seeing that there was nothing. So this one relies solely on your ability, so your understanding of the concepts and your ability to sort of reproduce that information that you know with reference to a person's first day at school. So they have given you a scenario, and the way that they marked it and the way that they looked at the question in the examiner's report did rely on you being able to address that scenario. So it wasn't enough to just spew out information about sensory memory and short-term memory and long-term memory if you didn't link it to what they wanted you to link it to. So again, it's really important to look at the examples that they provide. But this is the sort of stuff that you could look at. So everything that we've talked about essentially in learning and memory is what they wanted, is what you could have talked about. And again, marked holistically. So we have to acknowledge that you could have included a bunch of different things and you could have still had the ability to get 10 marks. But there was not a lot of people who got 10 marks. And that just indicates to me anyway, there are lots of people that were towards the lower middle. So it's not that people, and some people in the high, but it wasn't that people didn't know what to do. I think it comes down to being able to structure your response, have different sections, be really clear in your writing, and practice. And if you, I remember writing my plan, and halfway through writing my response in the exam, I stopped. I had no idea what I was doing, but I could look back to my plan and realize, okay, this is what you were going to talk about. So writing a plan is so important for extended response questions. And hopefully that if you have a read through what they sort of wanted, it gives you heaps of options and different ways that you could have gone about it, but it does accentuate the role and the fact that it's really important to include examples, even if there isn't a lot to work with. So I wanted to play this short little video, and then what I might do after that is I might quickly have a look at the chat, and we'll have a 5-minute just a breather, and then I'll come back, answer a few of the questions in the chat and move on to Unit 4.
Good morning, Skyline. My name's Tim Nolan. I'm one of the regional voice engineers for UBS, working across the Asia Pacific region, and I also do some work in the EMEA and US as well. My biggest career highlight to date, well, that's probably been relocating the Melbourne and Sydney office to their new current location, being involved with building their new data centres in those locations many years ago. Massive undertaking, a really long project, and I really got a lot out of that one. study pathway to get me to where I am in UBS. Well, I did electronics for my HSC many years ago, and I built a lighting recording desk, and I then got an apprenticeship doing my radio and telecommunications trade with Sydney Water. From there, I managed to get my electrical trade, refrigeration, air conditioning trade, and move through to some electrical engineering qualifications. From there, I morphed into IT and then started specialising in voice. So that's how I got from HSC to where I am today. Knowing what I know now, I know it's just weeks away for HSC, VCE for many of you. And I would say the process itself is more important than the mark. Things that you're learning is resilience, dealing with stress, dealing with uncertainty, especially with coronavirus, dealing with your fears, your anxieties. All those things are really important life skills that you need in the workplace, because every project, every task, you will be feeling all those things into your workplace depending on the situation you're doing, the projects you're doing, the level of risk that you take in your workplace, and the type of job that you do. So I would be saying to you guys, focus on the process rather than the mark, and allow the opportunities that are coming in front of you to unfold as they may. Well, that's about it from me, and I hope you have a great study week. Take care.
Amazing. And just to second that, as someone who can't imagine doing VC in the middle of a pandemic, let alone at home, not at school, I think just keep in the back of your mind that everyone is very, very aware of the circumstances, and don't put too much pressure on yourselves. The only thing you can do is your best, and literally no one's going to care after that. So I'll give you 5 minutes, and we'll come back at 3:10. I'll look through the questions, and then we'll get started on Unit 4.
My name's Elise, and I'm a graduate analyst at UBS, working in the metals and mining team. I graduated from school in 2015, and my Year 12 subjects were maths, chemistry, English literature, French, history, and biology. The one piece of advice I would give to myself when I was in Year 12 is just don't stress too much. You will have worked hard, so just trust yourself, trust your knowledge, and everything will fall into place by the time exams come around.
Hi, I'm Maddie, and I'm a third year cadet in global markets at UBS in the cash equities division. And I am a third year student studying at the University of Sydney, double majoring in financial maths and statistics and English. At school, maths and English were my favourite subjects, so I'm very grateful to have the opportunity to continue studying them after school. And I also look forward to sharing what I've learned and my study skills with you guys at Skyline. I know Year 12 can be very tricky for many, including myself, but the main thing is to try your best, work hard, listen to your teachers, ask any questions to fill gaps in your knowledge, and you won't have any regrets. You'll just be incredibly proud with what you can prove to yourself and what you achieve.
Great. So we'll start back now. Just to address one of the questions in the chat regarding, so the question was, is there a reason why some people generalize the stimulus after conditioning compared to people who respond to the CS only in a stimulus discrimination? So I think there's no like definitive answer, but the idea is that it's a biological thing. So we're likely to we associate, for example, the white rat with fear. And so anything that looks like the white rat, we then want to avoid. And that's why we might generalize. Stimulus discrimination, on the other hand, we try to condition it in people. So or in organisms. So if you think of the way that we condition puppies to only respond to our voice and not other people, that's also a process of conditioning. So it doesn't necessarily just happen. Sometimes that's something we intend to do. So one explanation might be that it's like an inherent biological thing. We're trying to protect ourselves, and as such, anything that looks like something that we're scared of, we inherently are going to freak out before we identify, where we do a little bit more research. And then the other thing is that stimulus discrimination sometimes is an intentional thing, that we're trying to stop organisms from behaving in certain ways to objects that we don't intend in them. Yeah, don't intend for them to behave in those ways. Hopefully that makes sense. We'll jump into Unit 4 stuff. Okay, fantastic. So we move on to sleep consciousness and sleep disturbances. So consciousness can be defined as our awareness of objects and events in the external world and of our own sensations, mental experiences, and existence at any given moment. So we have different levels of awareness that are experienced at different times, and so different levels of awareness have distinguishable characteristics that we can view or observe that make them different from other ones. So we like to think of it as a continuum. So on one end, there's total awareness, and on another end, there's complete lack of awareness. And in between, there are other states. So 2 levels of consciousness that we look at are normal waking consciousness, and that relates to the state of consciousness associated with being awake and aware of objects, events in the external world, and of one's own sensations, mental experiences, and existence, as opposed to altered states of consciousness, which are distinctly different from normal waking consciousness in terms of level of awareness and experience. So within that, we have natural ASCs, such as sleep and daydreaming and dreaming during sleep, that occur just in the normal parts of life. They're expected. We don't need any aid for these to happen. Whereas on the other hand, we have induced altered states of consciousness, and they're states of consciousness that are intentionally achieved by the use of some kind of aid. So for example, through meditation, hypnosis, or alcohol ingestion. We look at the role of attention, and we define it as the concentration of mental activity that involves focusing on a specific stimulus while ignoring and then excluding others. So the more attention that we have and the more attention that we're able to give, the higher degree of awareness that we have, and vice versa. So selective attention involves choosing and attending to specific stimuluses to the exclusion of others, whereas divided attention refers to the ability to distribute our attention and undertake 2 or more activities simultaneously. This depends on how much conscious effort is required for the various tasks in which we are engaged. So perhaps scrolling on your phone and paying attention to a TV show is a lot easier than scrolling on your phone and driving, because the amount of conscious effort that we require for driving is a lot more than for watching a TV show. Then we look at different ways that we can measure consciousness and physiological responses, as well as other techniques. So we start off with an EEG, so an electroencephalograph. And I've got just up the top of the corner, so DARE is an acronym that you can use for the definitions of an electroencephalograph, an electromyograph, and electrooculograph. So it's a device that detects, amplifies, and records the general electrical activity of the brain over a period of time. So the way that an EEG works is it amplifies and translates electrical activity beneath the electrodes that you're using into visual patterns of brainwaves. And then frequency relates to the number of brainwaves per second, so like little spikes, whereas amplitude is the intensity. So if you think of like big troughs and things like that. Now, usually we would have to look at the different types of brainwaves, but that was cut out of your study design, so don't worry about that. Then we look at the electromyograph, and it's used to detect, amplify, and record the electrical activity in the muscles. So the recording sort of indicates to us the strength of electrical activity that's occurring in the muscles, which indicates changes in muscle activity and muscle tone. So it tends to be that increased levels of muscle activity and muscle tone indicate greater levels of consciousness or more awareness than decreased levels. Then we look at the electroocular graph, which measures eye movements or eye positions by detecting, amplifying, and recording electrical activity in eye muscles that control eye movements. And it's used to measure changes in eye movements over time during different types and stages of sleep while dreaming. We also use other measures that aren't physiological, such as measurements of speed and measurements of accuracy. So measurements of speed typically involve responses or reaction times to a stimulus, how much time elapses between the presentation of a stimulus and the response time. And then when we look at measurement of accuracy, we're looking at the number of correct responses and incorrect responses made by an individual in relation to the total number of responses possible. So the researcher calculates this as a proportional thing. We also consider the role of sleep diaries. So they're a subjective reporting method which is used to self-record and self-report sleep and waking time activities over a period of time. So the way that sleep diaries are used is they're analysed by the researchers to identify patterns of behaviour or practices of relevance to the topic of interest. So for example, researchers might use sleep diaries on people with insomnia to discover what they're doing in the hours before they try to go to sleep. So perhaps if they're drinking coffee or alcohol, or if they are spending 2 hours on their phone, a sleep diary might enable the researcher to identify patterns in their daily behaviour that might enable them to make recommendations on how to go about, reducing the implications or the effects of their insomnia on their sleep patterns, maybe. We also consider video monitoring, and it's most commonly used in studies of sleep and sleep disturbances or disorders, where one or more cameras are used to record externally observable physiological responses throughout a sleep episode, including behaviours that we undertake when we're falling asleep and when we're waking up. So the way that we also measure different levels of awareness, we use changes in a person's psychological state. And there are 6 ways that we can do that. So one of them is looking at content limitations. So, and that when we talk about content, we're talking about the type of information that's held in our normal waking consciousness and how it's more restricted or limited than the contents of consciousness in altered states of consciousness. So for example, we might talk in our sleep and we might say things that we would have never said if we were awake, but that's because we can't exercise control over what we let enter our altered states of consciousness. However, we have a lot more control over our normal waking consciousness. We also look at control and automatic processes, and the difference being that control processes it's a type of information processing that involves conscious, alert awareness and a mental effort in which the individual actively focuses their attention on achieving a particular goal, whereas an automatic process is information processing that involves little awareness and mental effort, minimal attention, and might be able to be achieved while it doesn't interfere with the performance of other activities. We look at perceptual and cognitive distortions. So altered states of consciousness either make the senses more receptive to our external stimuli, or it dulls them to such an extent that some sensations we just don't experience at all. So the way that we think is often more disorganized, thinking is often illogical, difficulties making decisions, but also difficulties in sequencing. And I don't know if you've ever, my brother used to sleepwalk, and I think probably used to sleepwalk, but if you ever listen to someone when they're in an altered state of consciousness, things don't make sense. It's not coherent. That's the word. It's not coherent. Whereas in normal waking consciousness, we have ability to organize our thoughts in a way that when we speak, things make as much sense as they possibly can when we talk. We look at emotional awareness. So the level of emotions experienced by the individual are either heightened or dulled. Altered states of consciousness sometimes put individuals' feelings into a state of turmoil, resulting in uncharacteristic responses. So if you've been around anyone who drinks a little bit too much alcohol, their ability to control their emotions might mean the inability to control their emotions might mean they cry a lot more often. It's quite uncontrollable. It's not like them. They might get very angry. So our ability to control our emotions is significantly impacted. our ability to self-regulate our behaviors is also influenced, and that ties into how our emotional responses might be amplified. And our ability to perceive time and time-related experiences, so what's happening now, what's happened in the past, what might happen tomorrow. So in normal waking consciousness, we have the ability to travel through. We can say, oh, I went to dinner last week and I'm doing something today and I'm doing something next week. But in some altered states of consciousness, we might have difficulty in losing contact with where we are now, what time it is now, what happened yesterday, what's happening tomorrow, because our perception of time is significantly altered. And also, the experience of time is also altered. So if you've ever gone to sleep and woken up and it's felt like half an hour, but it's been 8 hours, that's a result of us being in an altered state of consciousness and not being able to actually perceive time in the way that we usually think we would. Then we look at the effects of consciousness on, so the research into one night of full sleep deprivation as comparison with the effects of legal blood alcohol concentration. So Dawson and Reed identified significant relationship between fatigue due to a moderate level of sleep deprivation, legal levels of alcohol consumption, and impaired performance. So essentially they found that on performance in a wide variety of cognitive tasks, that 17 hours of full sleep deprivation had decreased to a level that was equivalent of that to a person with a blood alcohol content of 0.05. So that's our legal limit. Performance following 24 hours of sustained wakefulness was equivalent to that of someone with a blood alcohol content of 0.10, which is double our legal limit. So, however, when we're looking at generalizing the findings of this study onto everything else, we acknowledge that this was their results, and perhaps they came to this conclusion. But when we want to generalize findings to the wider population, we want to acknowledge that, especially in this research case, the computer simulation involved relatively simple tasks. It was under controlled lab conditions, and they were really careful in terms of the impact of wider variables that also impact on human performance in measuring and then coming to a conclusion about the interactions between sleep deprivation and alcohol consumption. So for example, if you're extremely stressed about a work thing that you have going on, that might influence your experience of sustained wakefulness, and it might alter the way, like it just might mean that you're not necessarily going to achieve the same sort of blood alcohol level equivalent. So there are just acknowledging that there are a range of different factors that might also come into play in the real world, but this finding was quite alarming because, you know, lots of people work jobs where, like overnight jobs, night shifts, where they do operating heavy machinery. And I think that this study just accentuated how dangerous sleep deprivation can actually be. So now we move on to sleep, and we look at sleep and we define it in terms as, so it refers to the reversible behavioral state of perceptual disengagement from and unresponsiveness to the environment. So we have two different types of rhythms that sort of guide how we look at sleep and sleep cycles. And one of them is circadian rhythm, which generally is a biological rhythm that involves changes in bodily functions or activities that occur as part of a cycle with a duration of about 24 hours. And we look at this concept of the suprachiasmatic nucleus. And it's an area of the hypothalamus that regulates the timing and activity of the sleep-wake cycle and other biological rhythms, but is considered the biological clock. So the suprachiasmatic nucleus receives information about the amount of light coming from the eyes and adjusts our sleep cycle accordingly by sending neural messages to the nearby pineal gland to secrete more or less of the hormone melatonin into the blood. So the amount of melatonin present in the blood is associated with alertness. So higher melatonin levels, greater drowsiness, and vice versa. So we take cues from the sun on a 24-hour basis through a circadian rhythm, and that's how our sleep-wake cycle sort of develops. On the other hand, though, we also have at the same time what we call an ultradian rhythm, and that's a biological rhythm that involves changes in bodily functions or activities that occur as part of a cycle shorter than 24 hours. So an example of this is stages of sleep. So we'll go into it in just a second, but we have 4 stages of non-rapid eye movement sleep, and they occur in a rhythm, but a cycle shorter than 24 hours. Another example might be hunger. So hunger occurs in a cycle. It's a bodily function that occurs in a cycle that's shorter than 24 hours as well. And yeah, we just said that the sleep-wake cycle is internally produced, cued by environmental time-giving stimuli, which are used to keep it in sync with the 24 day-night cycle that occurs. So we look at the different stages of sleep, and we have 2. So we have non-REM, so non-rapid eye movement, and we have rapid eye movement sleep. Non-rapid eye movement sleep is divided into 4 stages and accounts for approximately 75 to 80% of our total sleep time. So it occurs, so we've got stage 1, occurs as we drift in and out of true state of sleep. We gradually lose awareness. It lasts for about 5 minutes, and we can be easily awakened during stage 1. So it has a low, what we call an arousal threshold, because we can be easily woken. Stage 2 is still a period of light sleep, but about midway through, you're unlikely to respond to anything except extremely long, strong or loud stimuli. And it lasts for approximately 10 to 25 minutes and lengthens. So it's get longer with each cycle. So stage 1, 2, 3, 4 in sleep happen again and again throughout sleep. The duration will change, but stage 2 gets longer each time that it happens. So stage 3, it's the start of the deepest part of sleep, and it's hence moderate deep sleep. Typically lasts a few minutes at a time, up to 10 minutes. People are difficult to get to wake up, but if you can wake them up, they're very groggy and disoriented, probably won't know where they are, sort of thing. Then we look at stage 4. It's the deepest stage of sleep with the highest arousal threshold, very difficult to wake. We've got no eye movements, and in the first sleep cycle, a person may spend between 20 to 40 minutes in stage 4, and then we spend less and less time in stage 4 as the sleep cycle goes along. Sleepwalking. So they did take it off the study design, but sleepwalking would usually occur, I think it was in stages 3 and 4, so the deep sleep, because while the brain is at, oh no, don't take my word for that. I'll check and I'll get back to you. But I think, yeah, deep, yes, the stages 3 and 4 non-REM sleep, but it was taken off your study design. So unless you're planning to use it as an example, then don't worry about it too much. And then REM sleep is a nice smaller one, only 1 stage, but it's defined by by spontaneous bursts of rapid eye movement, during which the eyeballs quickly move beneath the eyes. I'm not sure if you've seen anyone sleep, but that's what that is. The body's internal functioning is more active. It's also called paradoxical sleep, as internally the brain and body are active, while externally the body appears really calm and inactive. Most dreaming occurs in REM sleep. The periods get longer and they get closer and closer together as sleep progresses, because we have less of stage 3 and 4. So it becomes more of a, less 3 and 4. So we spend, as the sleep cycle goes on, as you might enter your 2nd or your 3rd or your 4th one, it gets longer. And it shares properties of both light and deep sleep. Then we have different theories to explain, well, why do we sleep? One of them is restoration theory, and it proposes that sleep actually provides a timeout to help us recover from depleting activities during waking time that use up the body's physical and mental resources. So the idea is that we're allowing for damaged cells to be repaired. Stages 3 and 4 of non-REM sleep are associated with physical growth and tissue repair and recovering from the effects of fatigue. So it's got that real restoring and repairing the body element to it. And in terms of REM sleep, it also provides regular exercise to groups of neurons in the brain that form neural pathways, which helps promote the maintenance of brain circuits. However, the limitations of this theory is that it hasn't actually been conclusively established in a cause and effect way what, if anything, is actually being restored. Research hasn't established that restoration is the only purpose of sleep. And then there's this whole thing where the brain is still active while we're replenishing. So really what's being restored, is it only for the body? Is it not also for the brain? And then that brings into question, well, how do we take it as a theory if it provides a purpose for one element of sleep, but perhaps not another? Then we look at evolutionary theory, and this theory proposes that sleep evolved to enhance survival by protecting an organism through making it inactive during the parts of the day when it's most risky or dangerous to move about, so at night, because we aren't nocturnal animals and we need light to do things, to function. So sleep then serves the function of protecting the sleeper from harm or death, and therefore enhances the survival of the species. But the limitations is it doesn't actually explain the need for sleep. It explains why it might have happened over time, but why do our bodies need it? And then it also doesn't account for the fact that when we are asleep, we lose awareness and alertness. So might that not make us more vulnerable? So that's something to consider. Then we look at the difference in how sleep and stages of sleep change over the lifetime. So for newborns and infants, more than half of infants' sleep is REM sleep, or active sleep that is like REM sleep. So their circadian rhythms are not fully developed. And what that means is that while we might do the thing where we, do things during the day, but then have long periods of sleep, that 24-hour cycle hasn't been established yet. That's why they're like asleep all the time. At 2 or 3 months, the circadian rhythm exerts influence, and then now there are longer periods of wakefulness during the day and longer periods of sleep at night. And then by 12 months, the infant sleeps 14 to 15 hours a day, with majority of sleep occurring as a single episode in the evening. So you might have a nap in the middle of the day, but most of it is at night. We move to children, and we say that while the total sleep time continues to decrease as children get older, from 13 to 11 hours between 2 to 5 years of age, the proportion that we spend in REM sleep continues to decrease. Then the amount of REM sleep increases, and we spend a bit more time in our slow wave deep sleep. And then about half of non-REM sleep is now slow wave sleep, and this decreases markedly from about the age of 10. So what happens as we get older, we get less of that deep quality sleep that we all really want, and that starts to decrease from about the age of 10. Then we look at adolescence, and the total sleep time decreases, as does the amount of REM sleep. Stages 3 and 4 non-REM are progressively declining. And then adolescents often get less sleep than they need to function optimally, and we'll touch on that a little bit in a few slides, I think. And then we look at adults. So adults, they average around 8 hours of sleep. 20 to 25% is in REM sleep. Eventually, we lose not all, but a lot of our slow wave deep sleep that we really, really want. And sleep tends to be more fragmented, with more awakenings among older adults. And that can be explained because we mentioned the arousal threshold before. If we don't have a lot of deep sleep, and we're spending most of our sleep in stages 1 and 2, a little bit of 3, but mostly 1 and 2, it means that we can be woken up a lot easier, which is why the little things will wake you up, and then that's why sleep becomes more fragmented. So we look at also how phase disorders, or circadian rhythm phase disorders, can influence the sleep-wake cycle. So circadian rhythm phase disorders are a group of disorders that involving sleep disruption that is primarily due to a mismatch between an individual's sleep-wake pattern and the pattern that is actually desired or wanted. So biological influences in adolescence, we look at so during adolescence, there's a hormonally induced shift of the sleep-wake cycle forward about 1 or 2 hours. So melatonin is secreted later in the 24-hour cycle. And what that means is if melatonin is secreted later, we don't feel drowsy until a lot later, which explains why we fall asleep a lot later. Unfortunately, that means that we accumulate this thing called sleep debt, and that sleep debt's owed and needs to be made up because daily sleep requirements have not been met. So it's a difference between the amount of sleep that we actually get and the amount of sleep that's required for us to function optimally. So so the main thing of the biological influence is that sleep-wake cycle is shifted about 1 to 2 hours forward by a decrease in the release of melatonin. And then psychological and social influences might include things like, typically adolescents like to exert their growing need for independence, which include making decisions about when they want to go to sleep, when we want to go to sleep, when we want to go out. And I think the increase in social demands, including academic demands, so the fact that we stay up a lot later to study, and perhaps that's not great for our not only our sleep and sleep depth, but our ability to actually function cognitively to the best of our abilities and retain information that we've learned. And then we look at shift work. So shift work is work that work schedule that's designed to meet the demands of a 24/7 society, and often that involves people working night shifts but sleeping throughout the day. So people often experience excessive sleepiness because during the nights, and it might impair performance because of reduced alertness. Work rosters with rotating shift work schedules are associated with a higher frequency of sleep disturbances. If you're a nurse, for example, and you spend 1 week doing days and then the next week or the next fortnight doing nights, that's not going to do amazing wonders for your sleep schedule, and it's going to disturb your sleep a lot more. Sleep debt may accumulate, and then we might actually have difficulty falling or maintaining sleep during the day after an overnight shift can occur, because our bodies just don't want to do that. And then we look at jet lag. So it's a sleep disorder due to a disturbance in the circadian sleep-wake cycle caused by rapid travel across multiple time zones. So there are various things that can be experienced as a result of jet lag, and might be difficulties in initiating or maintaining sleep, excessive sleepiness, reduced daytime alertness, impaired concentration. However, the symptoms of jet lag tend to be temporary and minor for the most part. The best way to resolve or to address the symptoms of jet lag would be to reset the biological clock for the sleep-wake cycle to the destination time as quick as possible. So you change your eating, sleeping, and other behavioral patterns to accord with the destination time. And that's just what we do. We go to a different country, and all of a sudden we're doing mornings when they're doing mornings, not when Australia is doing mornings. And that's just how we get out of that cycle. Then we look at sleep deprivation. So it's a term used to describe state caused by either inadequate quantity or quality of sleep, either voluntary or involuntarily. So we look at effective functioning, and we see how people who are sleep deprived might experience more amplified emotional responses. We lose the ability to process emotional information and regulate how to respond. And we might overreact to trivial matters because our emotional response threshold can be lowered. In terms of behavior, we talk about and we look at how sleep deprivation might result in sleep inertia, which the performance impairment that occurs immediately after awakening. So we have a bit of a lag. It can interfere with our ability to perform a wide range of behavioral and cognitive tasks. Excessive sleepiness during normal waking times, reduced efficiency. It can take me longer to write 100 words when I'm sleep deprived than when I'm not, because it's that much more concentration that we have to do. Cognitive functioning, reducing alertness, experiencing lapses in selective attention, difficulty making decisions, difficulty learning and retaining information, so it impairs our learning and memory processes. And then they change your study design very just to accommodate for Rona. So the only intervention that you have to look at is bright light therapy, and that involves timed exposure of the eyes to intense but safe amounts of light. So when we're using it for circadian rhythm phase disorders, the aim is to shift an individual's sleep-wake cycle to a desired schedule, typically the day-night cycle of their physical environment. So for example, if we're looking at a persistent delayed sleep phase disorder, so you're getting to bed, you're going to bed really late and we want to go to bed earlier, we're going to expose you to light exposure during the early morning hours, and that's going to help advance the circadian rhythm to an earlier time to shift it forward. So by exposing you to the light during the morning, it means that you're less likely to so the idea is that melatonin is going to be released earlier, not later, and that's going to help you try to reset that sleep-wake cycle. That's the word. Glorious. So that was sleep. Tim, were there any questions on that?
We didn't have any, only the one that you've already answered on sleepwalking, but maybe an interesting question for the group to consider, given over the previous years there's been numerous news articles, is do you believe that high school students should start school later in the day? based on all the stuff you've just revised.
Like it's, and especially like in the middle of, everything is amplified by in the middle of a pandemic. But like, I don't know, because of, I feel like it's definitely interesting because now that uni's, moved online, I don't start my uni days until 10 or 11, and I'm so much more productive than if I started at 8 or 9 in the morning. So I think it's, very interesting to consider. Hopefully they do, because like it's unfair.
Yeah, well, some of the news reports are talking like 10 a.m. in the morning, high school should start. I think Tara's definitely a fan.
I think it's a glorious idea, to be honest. Okay, so I've noticed that people are using the website that I shared earlier. So I know there are questions on there, so we'll do them on there. It was just in case people couldn't access it. So now we've moved on to mental well-being. So the first point talks about understanding the concept of mental health and sort of understanding it as a continuum. So we talk about mental health in terms of being a state of well-being in which an individual realizes their potential, can cope with the normal stresses of life, can work productively, and are able to make a contribution to their community. So we have mental health problems which adversely affect the way that people think, feel, and behave, but typically to a lesser extent and of shorter duration than a mental disorder. Whereas a mental disorder involves a combination of thoughts, feelings, and behaviors, which are usually associated with significant personal distress and impair the ability to function effectively in everyday life. So we look at mental health as being a product of internal and external factors. Internal factors are influences that originate within a person. So for example, and we'll discuss some of these later on, but for example, how much GABA a person produces. So the neurotransmitters, they're the internal factors that might influence our mental health. Also our ability to think, so our mental processing, are we people who are able to cope with things? Are we people that tend to go down the emotional focused avoidance, problem-focused coping, or are we approach? So that also has an impact. But we also look at external factors. So these are sometimes social, so include school and work factors, how strong our relationships are, how much support we have from others. And we talk about it, and we look at the biopsychosocial model as a way of describing, explaining how different factors combine and interact to influence a person's mental health. The study design wants us to look at typical characteristics of a mentally healthy person. So this includes high levels of functioning. So functioning refers to how well an individual can independently perform or operate in their environment. And the behavior is primarily, in people with high levels of functioning, is primarily adaptive and involves actions that enables people to carry out their everyday tasks. We also look at resilience and the ability to adjust and cope with and adapt to life stresses and restore positive functioning, and how it tends to be that people with high levels of resilience are able to, through their high levels of self-esteem and self-confidence and their ability to believe in themselves, sort of thing, they can approach different situations with a sense of optimism as opposed to a sense of pessimism. And then we look at high levels of social and emotional well-being. So social well-being is based on our ability to have satisfying interactions with others, including the ability to establish and maintain positive relationships and respect and understand other individuals. And we look at emotional well-being, which is based on the ability to control emotions and express them appropriately and comfortably, including the ability to understand, share, and regulate emotions, and exercise control over how we express our emotions as well. We look at, in terms of mental health, there are lots of studies and research that's done into various aspects of the big topic that is mental health. One of them is looking at different ways that we can alleviate symptoms of mental health problems or mental disorders. And that involves looking at determining whether or not certain medications are going to be effective. And the way that we do that is through research anyway, is we often test it through the use of a control and experimental group. And in order to control for certain factors, we implement certain ethical standards and research method procedures to help us do that. One of these ethical standards is informed consent. We briefly touched on it with little Albert, but it refers to the process by which a researcher discloses appropriate information to a potential research participant so that they're able to make a voluntary and informed choice about whether or not to participate in a certain study. So people with mental health disorders are vulnerable as research participants because certain cognitive impairments or the desire to alleviate symptoms of mental disorders might influence their capacity to make judgments and decisions about their participation in research, including the degree of harm that they might experience as a result of being a part of the research study. Now, this is specifically accentuated when we look at the use of placebo treatment. So, for example, if we're looking at the efficacy of a medication, we might have a control group that we give a sugar pill to, and the experimental group that we actually give our experimental drug to see whether or not it's working, and we can manipulate and observe its efficacy in a controlled experiment setting. However, what that means is that researchers are intentionally going to be withholding a somewhat perhaps ineffective treatment from people who genuinely need the treatment and therefore are allowed to remain unwell. On top of this, we stop people, in some research studies, we might stop people from taking their own medication that they're using now in order to observe the efficacy of the new medication. And that might cause severe discomfort or distress that can inhibit the recovery by taking them off their medication to take placebos instead. And it means that there might be adverse consequences such as their symptoms reappearing or mental health conditions worsening. So it's not that we can't have people with mental illnesses or mental health problems or mental disorders in experimental studies. It just means that we have to really be very transparent and be make sure they're aware of the possible adverse consequences that may come about as a result of participating in the study, and giving them the option to weigh the risks and the harms with the benefits of participating in a study. So that's really important to acknowledge in this case. Again, there's an example question here that you can use, and I've sort of tried to break it down. Again, it's only 3 marks, so but it explains just in clear words why you would, or how you would perhaps go about using this question and breaking it down. So we come back to this idea of stress and come back to this idea of mental health as being on a continuum, and we sort of mesh them together by understanding the differences between stress responses, anxiety, and a phobia, and then consequently a specific phobia. So we mentioned before that stress is just a state of psychological and physiological arousal when we're exposed to stresses that perhaps we believe are and we can't cope with them. Whereas anxiety is the next step up, and we say it's a state of arousal involving feelings of apprehension or worry or uneasiness that something is wrong or something unpleasant is about to happen. And then the step up from that would be a phobia. So that's characterized by excessive or unreasonable fear of a particular object or situation. And then a specific phobia of a specific object or situation might lead to avoidance behavior to avoid that object altogether. That doesn't minimize the implications of either of stress, anxiety, or phobias, but it just enables us to see how they're distinct from each other, but how sometimes stress responses might be involved in anxiety and phobias because that's how biologically we react to anything that might be a threat to us. So they've taken a bunch of things off the study design, but we're now looking at the relative influences of contributing factors to the development of specific phobias, and it's broken down into biological, psychological, and social. So in terms of biological influences that might contribute to the development of a specific phobia, we look at GABA dysfunction. So we mentioned it earlier on, and GABA acts, remember, it's our inhibitory neurotransmitter, and it acts as a calming agent or a brake to the excitatory neurotransmitter that leads to anxiety. So GABA dysfunction means that there's less GABA in the brain. So the fight, flight, freeze response might be more easily triggered because we don't have enough GABA to balance out the effects of the excitatory neurotransmitters, which may in turn predispose individuals to developing a specific phobia because people might be more vulnerable to anxiety. We also look at long-term potentiation and how the concept of strengthening associations between things and neural pathways means that as soon as the presynaptic neuron is sort of signaled, then the postsynaptic neural will come in because we've really strengthened that relationship. So the logic from that is that the stronger the association between a phobic stimulus, for example, seeing a spider, and you freaking out about seeing a spider, and the more times that happens, the more that's strengthened, and that perpetuates the specific phobia. Also biological, we look at the role of the stress response. So we say that the physiological changes that are associated with fight, and freeze might become a conditioned response to a phobic stimulus. Because remember, conditioned responses involve responses that are automatic. The fight, flight, freeze system is automatic. And thus we might actually, every time we come into contact with a phobic stimulus, we activate the fight, flight, freeze, and that might also perpetuate the existence and the occurrence of a phobic specific phobia. Then we look at psychological. So in psychological, we have behavioral models, and we acknowledge that specific phobias can be perpetuated by both classical and operant conditioning. So in terms of classical conditioning, if we look at I don't know what to say, but if we look at a spider again, perhaps we associate the spider with fear. And then every time that the more trials that happens, or perhaps sometimes even in one trial, we learn that the body learns that the spider will always produce that fear. The fight, flight, freeze response is always going to activate your sympathetic nervous system, and that might help explain how a specific phobia is developed. Operant conditioning helps us understand how specific phobias are maintained. So when we think back to the consequences of operant conditioning, if we learn to avoid certain phobic stimuluses, and that we learn that removes the feelings of fear and anxiety, then that's a form of negative reinforcement. So for example, if you know that there are spiders in grass, right, and you absolutely refuse to sit in grass, you avoid situations where there's grass, this is a very bad example, but you avoid situations where there's grass, and that acts as a form of negative reinforcement. You don't see the grass, you don't see the spiders, you don't go near grass, you don't go near spiders, that perpetuates your phobia. So in the future, any response that removes fear will also be negatively reinforced, therefore perpetuating phobia. So it can also contribute to the acquisition of a phobia through positive reinforcement. So if you experience a relief from being away from an environment that might result in your specific phobia heightening, or you being exposed to the phobic stimulus, then that good feeling is enough for you to not go in those places. Like that's a good thing for you anyway. So that's how it explains how behavioral models can perpetuate. Then we look at cognitive models. This is still under psychological ways. And we look at the idea of a memory bias. So we distort influences of present knowledge, beliefs and feelings on the recollection of previous experiences. So if we go back to my friend who's deathly scared of dogs, you blow up the original memory of your first encounter with a dog, or of the moment that you felt really, really scared, and that becomes it. You don't allow any further interactions or future experiences to outweigh the experience that you have from the previous situation. We also consider catastrophic thinking, and it's a thinking style which involves overestimating, exaggerating, or magnifying an object or situation and predicting the worst possible outcome. So going back to this friend, this person would not go next to a dog because they believe that they're going to get bitten and they're going to end up in hospital. This is just a made up example. Like they imagine the worst case scenario, so that they engage in a form of catastrophic thinking that perhaps strengthens the fear and anxiety response, and therefore contributes to the development and perpetuation of the phobia.
Malaise, a question's just come in that's probably worthwhile touching on before you move on. And it says, can anxiety be considered both a mental health problem and a disorder?
Yes, I think it is. I think anxiety disorders are classified as mental health disorders, but I think most people acknowledge that everyone experiences anxiety to some degree. I think the difference is anxiety is a normal part of everyday life. So it can be described as a mental health problem in that sense, but there are also categorized anxiety disorders, so it can be both. That makes sense.
I would agree. I would say that everybody experiences anxiety, but I think when it becomes clinical anxiety, we're talking about impeding your function for daily living, Tara. So, and then there's a whole pile of classifications in a book called the DSM-5, and that particular manual is what psychologists and psychiatrists use to classify specific disorders. And so when it begins to impede your daily function of life, that's when you sort of look at it as being a disorder rather than just being a mental health problem that you might have anxiety because of an exam, but then after the exam, it's gone away. I hope that clarifies it.
Perfect. Yeah. Okay, great. So now we move on to social factors that contribute to the development of a specific phobia. So we look at specific environmental triggers. So an initial fear response to a specific environmental trigger can become a conditioned fear response through classical conditioning processes. So we sort of touched on that before. And now that's produced whenever the stimulus is subsequently encountered. So the more severe the trauma that's associated with the unpleasant or harmful initial fear experiences, so the first time something happens, the more likely it is that a fear is going to develop. So that's looking at things in the environment. We also consider the stigmas around seeking treatment as some things that are, might contribute or also perpetuate an existing specific phobia. So stigma relates to this notion that perhaps people, the way that society views mental disorders and mental illness can influence an individual's desire to go get assistance and treatment because of how other people might view them and consequently how people might view themselves. So because phobias are what are known as irrational fears, sometimes if you don't understand how it happens or how it works or why people might have them, it can be really difficult for other people to empathize. And people who experience specific phobias might feel like they can't actually trust anyone or no one's going to take them seriously. So the nature of the specific phobia and its symptoms mean that individuals with a phobia are particularly vulnerable to experiencing stigma, which might affect their willingness to tell family and friends, let alone seek treatment from a professional. And then we're looking at evidence-based interventions that can be used to minimize the effects of specific phobias or things like that. So again, biological, we're looking at the use of benzodiazepine agents. So benzodiazepines are a group of drugs that work in the central nervous system, acting selectively on GABA receptors in the brain to increase GABA's inhibitory effects and make postsynaptic neurons resistant to being excited. So they calm the body down by reducing physiological arousal and promoting relaxation. They're classified as GABA agonists, which mean they initiate and stimulate the activity of GABA at the site of a postsynaptic neuron. And in turn, they inhibit activity at the receiving postsynaptic neuron. So they reduce the symptoms of anxiety through decreasing the excessive neural firing that occurs in times of high anxiety, because we're providing people with an inhibitory effect that's going to calm everything down when the body's instinct is to increase the body's function. Another way that we can go about trying to minimize the impacts of specific phobias is through exercise. So we try and promote relaxation and thereby providing relief from anxiety. We provide a distraction, or it might provide a distraction or a timeout from the phobic stimulus, from the fear and the anxiety. We might increase tolerance to some of the fear and anxiety symptoms because when we're exercising, we're increasing our heart rate and our breathing. Those are some of the symptoms that tend to come about when we're exposed to a phobic stimulus. So it might help us deal with those symptoms better if we struggle with breathing. And also altering brain chemistry, so it promotes the release of endorphins to provide relief from anxiety. And then we also look at relaxation techniques. So this looks at how can we maintain correct breathing when we're anticipating or exposed to phobic stimulus. So it might help reduce anxiety or alleviate its symptoms. So during a phobic reaction, people might breathe a lot faster and deeper than necessary, so they might hyperventilate or get into a pattern of uncontrolled, rapid and shallow breathing. So we try to we call it breathing retraining, because it's an anxiety management technique that involves teaching correct breathing habits to people with specific phobias. So the goal is to slow down our respiration and maintain the levels of oxygen, the correct balance of oxygen and carbon dioxide in the blood. And then we look at psychological interventions. So we look at cognitive behavioural therapy. And the aim of CBT is to change the thoughts and behaviours that perpetuate a phobia, and improve our coping skills. So avoidance behaviour and safety behaviours isn't helpful for someone with a specific phobia, as the individual tends to become reliant on them, which can perpetuate phobias. So what we're trying to do is we're trying to promote realistic thinking with the goal of alleviating fear or anxiety through education. We're trying to make sure that they're aware of the evidence-based interventions and they can use them or have alternative ways of perhaps looking at how they view their condition. We also look at systematic desensitization. And it's a kind of behavioural therapy that aims to replace an anxiety response with a relaxation response when an individual with a specific phobia encounters a fear stimulus. So the idea is that we teach a relaxation technique that they can use when confronting a phobic stimulus. It might be breathing retraining. We then create a fear hierarchy from least to most anxiety producing. So for example, if we're scared of spiders, it might be that we at the bottom is we read a passage about a spider. And then we might see a photo on our phone, and then we might look at one, but from a distance. And so we create a hierarchy of what would be like the easiest things for us to deal with to the hardest, and we work up. So then step 3, we systematically, gradually pair the items in the hierarchy with relaxation techniques by working upward. So perhaps in the first stage, when you're reading something, you might find that it's really easy and it's fine. But when you see the photo, you might employ the technique of breathing to try and combat the sort of automatic effects that your sympathetic nervous system is going to try and do, if that makes sense, hopefully. And then we look at psychoeducation as our social intervention, and that involves the provision of information about a mental disorder to individuals diagnosed with the disorder to increase their knowledge and understanding of their disorder and its treatment. So we look at 2 things. We're trying to challenge unrealistic or anxious thoughts because they might perpetuate the specific phobia, because we overestimate how bad it will be if they become exposed to the object or situation they fear, and underestimate their ability to cope. So we want to make sure that people are aware that their ability to cope actually outweighs their overestimation of their fear of the object. We also don't want to encourage avoidance behaviours. So it's important for families and supporters and friends not to encourage avoidance behaviours and sort of make people aware of the fact that they are engaging in avoidance behaviours, because not everyone is always aware of that. And then we look at resilience as a as a protective factor, so a good thing that helps us combat or minimize the implications of adversity when we face it. So we've touched on resilience, but the way that we look at this is biologically, so the way that an adequate diet can help us in terms of making sure that if we're eating the right sorts of food, we're ensuring that we have all of the vitamins and minerals that keep the brain and the body functioning well. We try to reduce the risk of physical health problems and improve things such as sleep, energy levels and mood, and that might contribute to improved mental health. We also look at making sure that we have adequate sleep, and this is really something I want to highlight. We talked about before the implications of sleep deprivation, and if you got a question asking you about how does adequate sleep act as a protective factor, or you want to bring up a protective factor, use knowledge across the course. So you know from the one of the last areas of study, you know the implications of bad sleep. Use that in your answer about why it's really important to have adequate sleep. You know that you know the same, yeah. So you know that information about why it's important, what happens if you're sleep deprived. Use that if you got a question about the research into sleep deprivation and blood alcohol content. Try to maximize, study hard, but also study smart, not hard. You can use different topics in different areas, and it reduces the amount of learning that you have to do. Cognitive behavioral strategies as psychological. So these are techniques that are drawn from cognitive behavioral therapy to identify, assess, and correct faulty patterns of thinking or behavior that might be affecting mental health and well-being. So, for example, cognitive restructuring aims to replace dysfunctional thoughts with more helpful ones, and this might help reduce problem thoughts as well as ways of feeling or behaving that are influenced by such thoughts. We also look at social support and how that can help people cope with mental health problems. People, this idea of being warm and nurturing can enable a person to be more confident about coping, but not only about that, but also about reaching out if they are not coping, if they know that their support system is there. We look at different types of support as well. So appraisal support, so help from another person that might help improve the person's understanding of their mental health problem and the resources that they might need to deal with it. We look at tangible support or assistance, which involves the provision of material support such as services or financial assistance or goods that might help offset the effects of a mental health problem if people are overwhelmed with that they can't do things practically in their own lives. We look at information support and how people and community groups and external agencies can also provide information with support with information about how to cope with a mental health problem, symptoms, or contributing factors. And then emotional support as well, which I think is really important. So families and friends in the community can also provide emotional support through expressing sympathy and by providing reassurance that a person is cared for, is valued, and will be helped in any way that they that is required. And so having all these different means of support means that a person that is facing a stressful event or a stressful time or a mental health problem can have a lot of different factors that might help them change the way that they view an event and help reduce the uncertainty and the potential impact of that event. Beautiful. So we're quickly going to do a brief hot tips for research methods, because I know how much everyone loves research methods, but we probably won't be as in depth, and then we'll have questions at the end. We're nearly there. Wow, that went quick. Okay, so important concepts and research methods for the exam. Understanding the things that go into a hypothesis, so that my teacher used Peter Pan is dead. So you want your prediction, it is predicted that, it is hypothesized that. You want your population, you want your independent variable, and you want your dependent variable. And if there is a relationship there, you want to be able to outline that in your hypothesis. It might be more of, you might not have to write a hypothesis in the exam, but being able to recognize the IV and the DV from a hypothesis is really important, because it might ask you questions about how to operationalize that later on. In terms of the independent variable and the dependent variable, we're looking at the independent variable being the variable that you're manipulating, the one that you're changing, and the dependent variable being the one that you are measuring. So you're looking at how the independent variable influences the dependent variable, and then you're measuring the dependent variable. In terms of operationalizing, all that means, it literally took me until October to get my head around it last year, but all it means is that you're defining the independent, the IV and the DV in terms of the scenario that they've given you. So for example, if you're looking at the effects of watching TV, so your IV, on levels of happiness, then your operationalized IV might be 1 hour of watching TV every day. So all you've done is defined it in terms of the experiment that they've given you. Your DV might be levels of reported happiness on a self-report Likert scale from 1 to 6 or whatever. So you're describing how the information is going to be collected, how it's going to be measured. That's it for IV and DV. So understanding the difference between your population and your sample. So your population is the entire group of people that you're looking to, you might want to generalize the information to, and the sample is the people, the participants in your study. So for example, if we're looking at stress and VCE students, my population would be VCE students, but if my study takes students from my school, then that's my sample because they're my participants, but they might reflect, we're trying to say that it would reflect VCE students in year 11 and 12. The types of experimental procedures, so we have repeated measures experimental design, whereby the same group is exposed to both conditions if you have two conditions. We have a matched participant design where you have two conditions, but you've matched a participant from each condition on some sort of characteristic that you're looking to investigate, or that you think might be really important to match in each group, but there are two groups, and then independent groups is just having a control and an experimental condition, group. In terms of participant selection, looking at random sampling, and that being that everyone in the population has an equal chance of being selected to be a part of the sample. We look at convenient sampling, which means that it's an opportunity sample. So you're selecting participants who are readily available without any attempt to make it representative of your population. And then we have stratified sampling. So you divide the population to be sampled into distinctive subgroups of interest, and then you select from those groups. Just note that in order for it to be randomized, you have to have random stratified sampling. It's also a good idea to just know some strengths and weaknesses of these. So for example, a great thing about convenient sampling is that it's quick, it's easy, it's inexpensive, but the weakness is that it often produces a biased sample. Stratified sampling is great because it helps ensure a high degree of representativeness from the population, but it can only be carried out if you have relevant lists of whatever you're looking for already. Otherwise, it's going to take, you might not have those lists, or it might take a really, 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 really long time to gather those lists and then divide the population. Random sampling is, great because it's highly representative, but it might be that it can be time consuming, and that there's also no guarantee that your random sample is going to be representative of the population. So being aware of those things might help you answer some of those questions that tend to come up, just involving why this might not be the best method of sampling. It's usually around convenience because it never provides, most likely it's not going to provide a representative sample. It's quite biased. Then we look at concepts like reliability and validity. And so reliability refers to the extent to which the results obtained from a research study are consistent, dependable, and stable. So it's this idea that if you were to take the same IQ test and replicate it, you get the same IQ in each test. So the measures that you're using are dependable, they're consistent, they're reliable. Whereas validity refers to the extent to which the procedures used for a research study measure what the research is intended to measure. So for example, an IQ test needs to measure IQ, otherwise it's not valid because it's not measuring what is intended to be measured. We have internal and external validity. So internal validity refers to the extent to which the results obtained for a study are actually due to the variables that were tested or measured. So that leads us into this idea of extraneous and confounding variables, and making sure that if your study has internal validity, that your changes in your DV were caused by your IV and not other factors that possibly could have manipulated the results of your study. External validity refers to the extent to which the results obtained for a study can be generalized to the population from which the sample was drawn or other people in the setting. So if we're saying that an experiment has high external validity, it means that the conclusions can confidently be generalized to its population and possibly to other similar situations. I would say if there was a question about whether conclusions can be generalized to the wider population, you never write that they can. You never write that the conclusions proved anything. You can say that the conclusions that, or the results and the conclusions that were found support the hypothesis, but we never say proved in psychology. And we always say, my best advice is, if you have to generalize anything, we're generalizing with caution, because we're acknowledging that we don't know if 100% if there were no extraneous or confounding variables that influence our results. We also know that in most experimental designs, there are controlled conditions. We've given one group a placebo. We haven't given the other group anything. We try to manipulate it as much as possible, and we can't say that that's going to happen in the wider community and society. So we can say you could generalize, but with caution, because, and you go on to explain why. That just plays it safe. You need to demonstrate you understand the concept of generalization and it's backed the conclusions to the wider community, but you also want to make sure that your assessor knows that generalizations aren't that easy to make. And then in terms of extraneous and confounding variables. Extraneous variables are variables that have the potential to influence your study, variables other than the IB. For example, if you're looking into the effects of coffee on test results, an extraneous variable might be the hours of sleep that a student has had before they drink the coffee and then do their test. So that might be extraneous if you identify it before you undertake the experiment and you try to control for it. If you don't, and if you notice at the end of your study that, we didn't check whether sleep has different levels of sleep could have resulted in the different results that we achieved, it might not be to levels of caffeine that were ingested by the students, then you have what's known as a confounding variable. You find out after, and there's nothing that you can do about it. It's just required that you make it apparent, that you say, we achieved these results, however, this could have had this result on the studies.
Liz, could you just spend a bit more time on your comments around generalization with caution? Are you talking more like you would say that your results are more linked toward the hypothesis, or how would you word that in an essay?
Answer. So when drawing conclusions, we want to avoid overstating what the results actually mean for our population. So the reason we say generalize with caution is because we can never be sure. We know that we control the experiment in such a way that it might be very irresponsible for us to say that, this is what's going to happen for the rest of the population. So what we can say is that perhaps the conclusions are relevant to what was actually investigated. The conclusions, so any influential extraneous variables have not been overlooked in our experiment. We can say that we've analysed and interpreted the results in a way that's enabled us to find an accurate finding about whether or not the hypothesis was supported. We can say that if we outline and we say openly that any gaps in the results and evidence that might be required are identified. If we acknowledge the limitations, if we say, we use convenient sampling, so that might undermine our ability to generalize to the wider population, or we use repeated measures, but we didn't account for an order effect where there might have been an influence of doing the experiment in this order rather than the reverse. So we're just acknowledging that there are differences in different steps of the research. There might have been things that undermine your ability to generalize. That doesn't mean that you can't make a conclusion, but it just means that we're careful in saying that this is how it is for the rest of the population.
Thanks, Malaise. I hope that helps, Gemma. Kind of think of it like you're going from the specific and working out. So your experiments are really specific, and the generalization is the entire population of the world. So as Malaise said, you continually refer back to your hypothesis of what, or if you're not talking about a hypothesis, you're talking about the purpose of the experiment. That's what you're trying to prove.
Yeah.
So if you say for some the hypothesis of your experiment is blonde women prefer red cars, you're making that as your experiment, you are trying to always support your statement, and it may not actually support the entire population, but it might only support the hypothesis of your experiment. Does that make sense, Gemma? I hope that kind of helps.
Perfect. So we've reached the end of the PowerPoint, but we're going to go to the questions really quickly. So bear with me while I get onto them. While I'm doing that, for any questions about how the slides are going to be given out, how the recordings are going to be shared, what's going to happen is, so the link that I put in earlier around the evaluation of how you felt about the session today. So once you fill that out, there'll be a section in there for you to put your email. Once we've received the evaluation, you'll be able to access the recording and the slides. They'll be emailed out to you. If you doing other subjects but didn't get to access the session for that subject, if you go onto the Skyline website, you'll be able to access, there's a section regarding today. If you put your email in and request session recording and slides from another subject, you'll be able to get those as well. Yeah, so psychology is really hard because it's just the content heaviness. The best thing that you can do for psychology is the practice questions, simply because after you do so many exams and practice questions, you realize they can only ask you questions about content in so many different ways. And it's probably it's not supposed to be happening, but you become so familiar with the information that you know how to structure it, you know what they're looking for, and it's a bit of a bang, bang, bang. I would say most likely you're likely to do better on the multiple choice and the short answer. Spend less time doing multiple choice questions. It's not worth, if you're good at it, it's not worth your time. Otherwise, cue cards, Quizlets, getting a big sheet of butcher's paper, putting it on a table on a wall, and putting in, so what I used to do is I'd put in, so for example, like mental health or mental well-being as a topic, I'd have the study design next to me and I'd just write out things from the study design. So for example, different factors, or I'd just write stress, anxiety, specific phobia. And if I could say the things out loud of what they meant, that meant I knew it. And to go back to study, I was a big Quizlet cue card person. Testing people and getting people to test you was also great as well. I know psych is a hard one just because of the content, but I found it so enjoyable just because this is stuff, like I'm doing a minoring in psych and this is stuff I'm still learning about, so it's relevant at least. Dot points to answer the 10-mark question. I would avoid it because the holistic thing part of it wants you to write in prose, so like you're writing essay, but use subheadings. So like my biggest issue when I started the year was that I was doing like essays, and that was horrible, and my teacher said don't do that. Use the different sections of the 10-mark that they give you, and have it like you have so it might be, for GEDAs you might have biological responses, gas model, alarm reaction, write about your alarm reaction, resistance. So you can section it out like that, but dot point seems too informal for them. They like you to be writing essay style, but you can use subheadings. Oh, absolutely no clue. Horrible with numbers. What did I do? It depends. It depends how the exam is. It depends how hard it is. Yeah, I honestly won't even be able to try that question. Don't worry about that too much though, because if you spend time worrying about this, it's gonna freak you out. Don't do it. My advice. Oh, I have no clue. I'm really bad with numbers and study scores, so it really does depend how you do in the exam. So how did I go? I don't think I got below a 96% in all my SACs, and I think I 42 or something. So it really just does depend on the exam. I found the exam a lot harder than the past exams. I have a feeling, an inkling that this year the exam is going to be a lot better just because of pandemic. But again, don't worry about this. Like it depends on the exam, the way that things are weighted. Don't worry about the numbers, worry about the content. Oh, I love this question. So I'm doing arts at Melbourne, Bachelor of Arts, and I'm majoring in criminology and minoring in psychology. I want to do law afterwards, so JD. So that's the pathway I'm on. But there are so many things that you can do. Depending on the subjects that you take as well, your interests might peak in different things, like developmental psychology, personality psychology, is social psychology. I didn't think I'd like, but I'm absolutely adoring. Behavioral neuroscience, like it depends what you'd like. I have a friend that's doing subjects similar to this, and she's looking at doing forensic psychology. You could do, there's so many jobs in the criminal justice system. It really depends, like the world's your oyster, but maybe like the different uni websites have drop downs of lots of different jobs that could come out of it. And reading through some of the descriptions of subjects might help pinpoint what you want to do as well. No clue, absolutely no clue. Honestly, anything about scaling and final exam scaling or SACs, do your best. Like, what can you do other than your best? AMPA and MDMA. I don't think so. I've never had to answer. Sorry, did the person who asked this want to just remind me what section it was in? Or not, that's okay. I never referred to AMPA or MDMA in any of my responses. So I think it's, unless it's to do with stress, but I don't think so. Terrible, good in my SACs, and I do terribly in the exams. The exams have a little bit of weight to them, but at the end of the day, I didn't think of the exam as a whole. I thought of it as sections. So you've got a few marks in the multiple choice. How can you maximize your marks there? You've got a few marks in the short answer. How do you maximize your marks there? Is it that you learn, perhaps you know you're not so great with the 5 and 6 markers, but you nail everything from 4 down because you're really good at pinpointing where the marks are? Think of them as separate sections. Try to maximize your marks in each one. It'll add up. Yep, ask that. I studied way too much, and yeah, you just for the weeks leading up to your exam, you're gonna have no life. But like, treat yourself nicely. Like, I watch Grey's Anatomy all the time because that was my like guilty pleasure. But yeah, you study all the time. Practice questions. Stop doing practice questions a few days out. Like, I would recommend a week out. Just review your notes. Maybe do multiple choice because they're easy and you can just refresh content and things like that. But don't push yourself too hard in a couple of days before. You definitely can redeem yourself on the exam. Again, if you look at it as different sections and try to maximize your marks in each section, it's that's how I thought of it, and that worked really well for me. I mean, hypothetically, yes, because you're going through, the body doesn't distinguish between, or at least GAS says that the body doesn't distinguish between good stress and bad stress. So if you had eustress for a very long time, you could also experience releases in cortisol. When Jita experienced the cold, why was she in resistance rather than exhaustion? Because when cortisol is released, it can have the effect a lot quicker. It doesn't have to be, it doesn't, I think Tim mentioned it before, now that you put it to an example, 15 to 30 minutes, I think, or something. So it can happen a lot quicker for some people. And again, we have to realize that GAS undermines the individual differences thing. So if we apply the stock standard GAS model, it might be really hard. But I think, yeah, so cortisol was just released because it's released in resistance. It's on the table. How many extended response questions? There was only one for me, as in one question that's worth 10 marks consecutively. There'll be questions that are worth upwards of 15 marks, but it's sectioned down into 7A, 7B, 7C, and then each question's worth a little bit more marks, but there's usually only one that's 10 marks as a whole. What did the D detect? So it's detect, amplify, record electrical activity. What types of jobs do you get in forensic psychology? I have no idea. I'm assuming things to do, you'd work closely with the criminal justice system. Tim might know.
Yep, criminal justice mainly. Forensics, you would also work profiling. You would be working in prisons, that sort of stuff.
The fun stuff.
Yeah.
Do we need to know what the SAM and HPA axis for the exam? I did know it, and it just enabled me to, there's this concept of beefing up your answers, and without knowing how systems like SAM and HPA axis work, you might find yourself that you can only say that the flight system increases, increases the body's activation or whatever, but the question might be worth 4 marks, and that might only get you 2. So I would say maybe if you're struggling to understand both, definitely understand one. It just helps. Some questions will be worth more than what a basic answer would give, if that makes sense. So yes, you can use the terms, no, physiologically and biological are the same thing. If you're talking in terms of stress responses and things like that. Neural structure change during the learning process. So neural pathways and neural networks get formed through the strengthening of synapses, and that strengthening of synapses in itself is a neural change. So the more that we learn something, the more that you put your foot to the pedal and you learn how to ride a bike, the more that those actions are repeated, the more that neural network is strengthened, and that's how we learn things, because we maintain those networks and we refer back to them when we need to do certain things.
Malaise, the question before that one talked about SAM. What did SAM stand for?
Sympathetic medullary, adrenomedullary, so it's a brain-body pathway. So it's interaction between the sympathetic nervous system, the adrenal glands, and the I think it's adrenomedullary gland. So it releases the hormones that you need for your stress response.
Cool. You got that right? Give us a thumbs up.
Can we use abbreviations without, if it's used in the question, yes. So if the question asks, how does LTP contribute to yada yada, or describe the role, yes. If it's not in the question, and might be a long answer, you use it once, and then in brackets you put LTP, and then you can use LTP throughout the rest of your answer. Similarities and differences. So funny you say that. I have a tiny little. When we talk about the differences, so the similarities is that there's an acquisition process between acquisition process where we're learning a response to a behavior or a stimulus. They're both types of conditioning that are achieved as a result of repeated association of events. In both types of conditioning, extinction can occur, stimulus generalization can occur, discrimination can occur, those features. But then for classical conditioning, it's an involuntary automatic response, whereas operant conditioning, it's voluntary behaviors that are guided by consequences. What else do we say? The learner is passive in classical conditioning, whereas in operant conditioning, the learner is active. So there are a few similarities and differences. When considering children, considering their withdrawal rights, does the participant need an advocate? Children can't give consent, their parents would give consent for them, so you would need an advocate in that sense, or guardians, or whoever is there. So like little Albert's mother would still need to be around because they're the person that are giving the informed consent, not the child. Before a memory becomes procedural, does it first become an episodic memory? So the memory of you riding your bike for the first time is an episodic memory. The actual, when we talk about memory of like the memory of your muscles, so motor memory, that's the procedural element. So that element, it doesn't become episodic, but your memory of the first time you rode a bike, it was sunny, you were at the park, that's episodic. But the motor movements that's a procedural memory, implicit. Cognitive and perceptual distortions, they don't distinguish between cognitive and perceptual distortions. They give them to you as a phrase, so don't feel the need that you have to separate them. You can say cognitive, if you wanted to, the cognitive aspect is things like decision-making skills, your ability to process information, whereas perceptual is things like how you perceive time, events that occur, things like that. Besides becoming a psychologist, do you know any other career outcomes? Tim?
HR, any management stuff. Think about psychology as understanding people around you. So a lot of HR people have done psychology and then done postgraduate stuff in HR and stuff like that. So anything where you want to learn about and understand and interact with people and in social environments, doing psychology rather than becoming a psychologist is great. If you're thinking about, besides becoming a psychologist, you can look at stuff like sociology, applied social science, social research. There's lots of those sorts of things around that use psychology and do subjects in psychology. So my undergrad degree that I did later on in life was an applied social science with a major in counselling and psychology. And then my master's has been in policy and applied social research.
Yeah. And then teaching is also an option too. Just if you like it. Motivation tips. This will be, when are your exams? I'm not sure when your exams are, but let's just hypothetically say they're in a month or less. This will be a really rough 3 weeks, 4 weeks. But after that, I'm telling you, you will be on such a high. It will be incredible. Just do your best. At the end of the day, that's all you can do. I know that it can be really, I'm someone who's stressed out an insane amount and put way too much pressure on myself. If I could go back and do it again, I would stress so much less, because at the end of the day, if you've done the work, you practice your questions, you rock up on the exam day, you've eaten, you haven't had a coffee because it's a long exam and you're going to be shaking, don't do that. And you just give it your best. You answer all the questions, even if you have no idea, you put something down on a piece of paper, you'll walk out of it and you'll feel so much better. Yeah, how do you stay motivated? Also so I'm not sure how long people can stay focused for, but for me it was 25 minutes, take a 5-minute break, do that 4 times, take an hour and a half off, do it again. Don't force yourself to sit there at the computer screen for hours on end if you're not going to get anything done. It's so much more important that it's so much more important for you to be really productive in the time that you do spend studying than taking a long time and not getting a lot done. So in saying that, I'm just going to share back my screen so you can do the last little bit of, study tips would just be, I think I've said it earlier, but it was,
I would also say on that previous question, Blaise, that your, what do you get what are you looking at? You're looking at like your university entrance mark. That's really only looked at for the next couple of years. And it doesn't really define your future. Yes, it's important. The process is important. But I went back to uni at the age of 35 and did my degree. And I've changed careers probably 2 or 3 times. And each time needed more retraining. So I think if you think about what am I going to do for my entire life and start thinking longer term, just take the pressure off yourself and just do as well as you can.
Yeah, that's all you can do. And once you get into uni, no one even cares. And if uni isn't what you want to do, then it's not going to matter to you anyway. And if you're taking a year off, then you're going to forget about it in the day after. It doesn't matter anymore. So yeah, please be kind to yourselves, but give it your best because you're here and you might as well do it. So thanks everyone for being here. I noticed some people have dropped off, which is really fair because I went a little bit over, but it would be fantastic if you could just finish up the evaluation, just so we know if you benefited from this. I really hope that you did. And yeah, so just a reminder, once you pop your email in, you'll get the recording and the slides. And I really do wish you all the best with your studies this year. I understand that doing it during a pandemic deserves all kinds of different awards, but once you get to the end, you'll be done and you'll be really, really chuffed with yourself that you stuck through it. So good luck. And thanks, Tim, for being here and helping facilitate it as well.
No problem at all. Thanks, Malaise, and good luck.
Thank you.